Good morning, everyone. Can you all hear me?
Yeah, Jivanti, we can hear you.
Okay. So welcome all of you to the opening plenary session of the 5th LKNOG conference. As the host LKNOG from Sri Lanka, we warmly welcome all of you to the conference. So I will hand up the session to Tilina to welcome all of you to our conference. Tilina, Mr. Tilina Patirana, the president of the LKNOG.
Thank you, Jivanti, and good morning, everyone. So we are doing the LKNOG5 live from Colombo and online. And we are jointly with SANOG 37 conference and workshop. So last 3 days, we were having SANOG 37 tutorial sessions. So most of you have been there by now already. So today we'll be focusing on the talks of LKNOG5, and the first session will be the keynotes, and we have 3 keynotes. I saw Dr. Prasad and Dr. Asitha already logged in, and I'm waiting for Mr. Prasad, who is Mr. Oshada, who is the Director General of TRCSL, and he was messaging us that he will be here in a moment because of some meeting he's having. So that's it. Good morning, everyone, and we hope you will enjoy the LKNOG5. Jivanti.
Yes, without taking much time, shall we move to the keynote speeches then? Okay, this is the opening plenary session. In this session, we have 3 keynote speeches by the telecommunication specialist in Sri Lanka.
Okay, so technical issues comes every time, so it seems like Jivanti is having some connectivity issue. So I would like to invite Dr. Prasad Samarasinghe, who is the managing director from Lankabell, one of the ISPs in Sri Lanka. Dr. Prasad, please.
Good morning. Can you hear me, Tilina? Tilina, can you hear me?
Yeah, we can hear you.
Can you hear me?
Yeah, we can hear you.
Yeah. Thank you for GNOG and all the organizing committee for inviting me for this wonderful event. And my today's task is for you to think a little bit about the IoT connectivity. And sometimes we are not categorizing IoT, and sometimes we are complicating IoT with the speed. And sometimes we try to solve problems from a minority than the majority of IoT. And whatever we do, end of the day, it has to have a business sense. And I would like to take you to the first slide. That is, talk about the business. Even the little predictions is 2017, we had 4.6 billion connections for consumer IoT. Industrial IoT, 2.9 billion connections. And the forecasted, the 2025 is 11.4 billion and 13.7 billion, which is really happening today. Because of that, is a huge industry for the future. And because of the volumes, is the components also building, developing, and there's a huge market for that as well. And whatever we do should have a link to our general life. And all these things will improve our life, quality of life. And there's a value for everybody. In that sense, is I'm talking about the more like a connectivity only. I'm not talking about going to talk about the other components. Certainly all these things are linked. So if you talk about the IoT, these are the few examples. Whether we use in Sri Lanka today or whether we use in South Asia today, certainly we apply. We have here and there, but we are not talking about the complete coverage. Or we are talking about today the complete benefit to our society. Certainly we have just started kind of thing in South Asian countries. And these are only few. And if you think that's a limit about the IoT applications. Whatever you do, even maybe some patients can check their blood sugar level then and there, instead of going and taking the results from the lab. And the same way they can get the prescriptions or the medicines also into that. Everything can be converted into complete automation. And for us to do automation, we have to get the sensors. We have to get the status. These IoT devices are more focused on that. We get the status so that we can react on this. The IoT is more like a bidirectional as well. The connectivity component of IoT. The IoT talk about the connectivity more like a machines, more focus on that. The machine-to-machine communication or the getting the information from the machines. Any technology can be used. There's no special ones. But if you take about the distance, if you talk about the RFID, the very small distance. And vertically, we are talking about the data speed. The data speed also very low. And what you can do with RFID, very closest and very slow speed, or the very small data can be transferred. And even today, you see a whole lot of application related to RFID as well. That is more like a communication methodology. And this diagram, I'm not going to explain everything, and this diagram shows about that. But the cost level, if the more and more darker means the cost is high. The cellular 5G, 4G, if you are going to use it, cost is high. But below that is the mainly our focus today actually. There's a low power wireless access networks. The LTE-M is one option, NB-IoT is another option. Can go up to 10 kilometers. And the speed is something like 100 kilobits per second. But if you are talking about the video surveillances or autonomous cars, sometimes they need much more the speeds or the much more data than the LTE-M or NB-IoT. Then you have to take to the next level of the speed. This gives you the cost feeling, the speed feeling, and the distance. But if the distance is less, means you have to have the towers or the base stations much more closer than this level. But it will have a link to the cost and the coverage. And if you don't have coverage, if your application is superb, then there's no value because there's no data connectivity, so that you will not be able to take action on that. This is a complete spectrum actually, and we are more focused on CAT-M and NB-IoT. The LT-CAT-1 is, if you take everything, you will understand the same scenario. It's more like a table form. The battery life is important. Why? But if you're going to put a sensor into something which is not really day-to-day accessible, then you have to have the larger battery life. These are part and parcel of IoT game plan. Say IoT has a data rate concerns, battery life, at the same time the cost. If the cost is high, you will not be able to put more and more IoT into get the information from the devices. But if the cost is low, sometimes you can deploy even 100,000 IoT devices to get the more and more accurate information. And then the VoLT is talking about actually the voice communication. If you are not going to take 1 and 2, you will not be able to communicate voice through this network. NB-IoT, you will not be able to do communication through voice, but CAT-M, they enable voice as well. But at the same time, the CAT-M has a issue on the battery life, cost, and then whatever we do, we have to worry about the security as well. The security level and the ecosystem. That means the compatibility and all, that is actually the 3GPP is defining the release 13, 14, 15 and more related to IoT, so that if it is compatible, so that everybody can do, all the devices will be compatible with the network. This gives the same thing in a more tabular format. And the same scenario, but sometimes we will need the massive connections, so that if you are going to analyze the maybe temperature, maybe humidity, maybe whatever the information you need, the more and more accurate, so that you will need the more or the massive connections. And sometimes the indoor coverage also important. If your fridge is connected to the network, if your fridge is in the basement, then you need the connectivity to that. But sometimes the information you want to take it from the fridge will be very small. You don't need the high-speed connectivity. You don't need the huge bandwidth, but you need the in-building penetration. The similar thing, but 3GPP is talking about the standard, so that whoever is going to build it will be compatible with somebody else's network as well. The devices and network will be much more compatible because of the global standard. The licensed and unlicensed spectrum, I'm sure the DGs will talk about this as well. And the licensed spectrum is, you have to have the operator license to drive it. Even though NB-IoT is part of LTE spectrum, you don't have to go and ask a separate approval, which is inside your LTE approval in Sri Lanka. It may be different to other countries. In Sri Lanka licensed spectrum, if somebody is having 4G license, they can build their IoT network on top of that within that frequency range. But there's an option for anybody to build, may not be operator, any other to build in an unlicensed spectrum. As per my understanding, which is available in Sri Lanka, but the problem is the recovery model. If somebody wants to build a network across the country, they need the infrastructure as well. They need the customers to recover it, which will not be that easy. But the unlicensed spectrum is open, means if somebody has a limited area, maybe factory, they want to build a network on their own, certainly which is available. I'm sure this is available in the other countries as well. I'm not exactly sure which country. Surely European, American, yes. But Sri Lanka, as per TRC, yes. I'm sure Director General's DG speech, he will talk about that part. This is a little bit of detail technology level. But if you're going to take in-band or the guard band, or you can have a standalone. Standalone, this we are talking about NB-IoT only. Standalone is like a 200 kilohertz carrier you need it. But guard band is 180 and inside also 180 kilohertz. That's mean very small band, but still you are taking out from the normal LTE data and give it to the NB-IoT. With this level, you can build your network. But if you have already built a network 4G network, but actually enabling this is only a software license. You don't have to go and change the antennas. You don't have to go and change any base stations, but only software license. Enable it, it will work. Why 4G? On top of that 4G, we need the NB-IoT. The reasons what I discussed earlier, the coverage will improve. Even though data rate is low, and it will penetrate more inside the buildings, so that the coverage and the connectivity will have a much more improved version than the normal 4G. In that sense, your machines, any sensors, connectivity will be much easier on NB-IoT. And this is a roadmap on that. And the NB-IoT and the IoT connectivity. The 5G era, even the NB-IoT will remain sometimes. It can go inside 5G as well because of the slicing. And if you talk about the video surveillances or the connected cars, sometimes the small speed will not work. Then you need the high speed connectivity. There are either 5G or 4G requirement will be there, but it may not be the majority of the IoT connections. The majority will remain under NB-IoT. They are the coverage solution the NB-IoT will be able to solve very easily. But if you want the high speed, maybe a good example, video security or the surveillance. There you are, if you are going to process video streams, you will need a high speed connectivity. There you have to think twice about the coverage as well. Either you have to build your own Wi-Fi network, or you have to check your coverage before you implement this kind of applications. But when it's come to Sri Lanka, it's interesting to see the 2017, the test NB-IoT network launch during Techno 2017 by Mobitel. And the today's situation, even the dialogue, the live connections are available. They work with LECO to connect the meters. So then you will not see a meter reader tomorrow, where they will take the meter reading automatically. And the exact date they can do it. At the same time, maybe even the progressive bills they can give it to you. Or they will implement prepaid electricity meters. If you have a connectivity to machines, maybe a good example, meters, you will be able to do much more application, but we can't think even today. Say the today's all electricity in the country, in Sri Lanka, is postpaid. The once we launch it, or they already launched, but expand it, and they will offer even the prepaid connections, so that you know how to manage your budget. These are the few examples. Surely Airtel and Hutch also on the same path, even though they haven't done it. But the situation is, whether the network ready is not a problem today, which is available by Mobitel and Dialog is confirmed, and other two operators also will come on board. Is the message to the other Sri Lankans, let's do the applications, start it and drive it, so that we will be able to make use this network for your NB-IoT connectivity. This is about the NB-IoT connectivity and what is available in the country. The country availability is 100% today. Or we can make it like 93% connectivity is available for IoT devices. The only thing, if it is not enabled, certainly you can talk to two operator and mention it, they will do it. Surely the other two operators also will come on board very soon. That's all about the discussion today, but I would like to thank Mobitel and Dialog for sharing their information also with me. And if there's any questions, anything, I'm happy to answer now. Or we can move to the other keynote speakers, and then later we can have discussion. Tilina, over to you, Tilina.
Thank you, Dr. Prasad. Jivanti, please.
Yes, thank you for informative presentation, Dr. Prasad. So I couldn't introduce you. Dr. Prasad Samarasinghe is currently the Managing Director of Lankabell and Managing Director of Telecom Frontier and Bell Solutions. So one of the leading telecommunication specialist in Sri Lanka. And yes, if you have questions, it's time to ask now. Yeah. So thanks again, Dr. Prasad. But there will be lots of questions from you for you. So hope you will be remaining till the end of the session. Okay, let's move to our next speech. Our next speaker is Dr. Asitha Bandaranayake. Dr. Asitha Bandaranayake is a senior lecturer at the University of Peradeniya and the consultant CTO of Lanka Education and Research Network. He's going to speak on reimagining the National Research and Education Network and their opportunities and challenges. Welcome you, Dr. Asitha, to the conference. It's time to deliver your speech now.
Yeah, thank you very much, Jivanti, and good morning, everyone. Yeah, sorry, Prasad, sorry for cutting you off. Okay. Okay, once again, good morning, everyone. So as Jivanti said, my topic today is going to be about reimagining the National Research and Education Network, opportunities and challenges. Basically, looking at our NREN and its operation, what we are currently looking at is about reimagining education. Now, with the pandemic that we have experienced over the last 15-16 months, the entire country, actually globally, people have come to realize the importance of reimagining the education, especially in terms of technology and so on. Now, this is nothing new. Introducing technology and ICT and digital literacy into the education has been there for a long time. This is from the World Economic Forum in 2015, where we identify, ICT literacy as well as or digital literacy as a key fundamental literacies that should be there in the education. And we also talk about things like these competencies where, communication, collaboration, and creativity or innovation, which we will talk about in a bit. So this is the core that the 21st century learning it's supposed to be built upon. And this needs few more things to come along, like assess standards and assessments, curriculum, professional development, and the learning environment. So this learning environment, as well as the technology skills, are the main things that we look at from our NREN perspective or from Learn perspective. Now, when it comes to this learning environment, we are looking at how can we reimagine the learning environment with technology. So the discussion has been with what we call online teaching and learning or blended learning and so on. But ultimately, what we are really looking at to provide what we call anytime, anywhere learning for anybody, right? So the flexibility of time, space, and using a wealth of information that is available globally, so that the inequalities are not further enriched as we go along, right? So, so when we talk about this one, the challenge that we have identified, which we have identified as our vision for learning, is we have looked at it in 3 different ways. So the first one, the challenge or our vision is to provide equity or justice, which would be the more loftier goal, but at least equity, where the inequalities would not prevent anybody from actually reaching higher. So I mean, if you look at the Sri Lankan context, we have the state universities, which is supposed to be of the same status, but if we go into the systems, you will see that the infrastructure is not the same everywhere. So even though you get into the universities, the state universities, they are not getting the same opportunity to further in their education. So how can we, as the National Research and Education Network, find a solution for this one? So that is the first vision that we have. So basically, the idea is to remove what we identify as systemic barriers, meaning that anything that, if you have to worry about the connectivity, the security, the workspaces, the devices, and so on, then you cannot really focus on what to learn, how to learn, and to get yourself further ahead. Right? So if you can remove these systemic barriers, then we provide everybody with an equal opportunity to actually utilize or focus completely on the education and moving ahead in their lives, and contributing to the national development. So that is basically what we identify from this one, right? So this is actually from the National Education and Education Technology Plan from US, but this is the same vision that we have actually come across. Then we realize that it is the same from there as well. So we look at about the learning, we see that we need to focus on the accessibility, the devices, the connectivity, and the resources. If you have that, then we can actually enable the learning process, right? So there are many things that comes together. We will be mostly focusing on high-speed connectivity. At the moment, that is what we are mainly focused on, right? As learn. But whether we can also, how can we ensure that this entire infrastructure is provided to enable this learning? So that's what we are looking at. How to go about doing it. So there's a lot to do in that sense. So which we'll discuss in a bit. And the other thing is, as a developing country, that and especially serving for lower income students, less privileged, disadvantaged students, we are looking at how can we provide more for less, like all the services, because at the moment, if you want to learn, because this information is available, and then there is enough information regarding how to learn, what to learn, and all the things are available. But whether they have the devices or the servers or the platforms for them to learn these things, so that and even if they're available, is it economical for them to use? So those things, can we provide, even at a university, higher education institute level, can we provide more for the same or less, and enable and ensure that they have these resources? So that is another thing that we look at. And also not just the services or the platforms, but access to information, where we look at providing equal or better quality access to everyone. So at the moment, from through Learn, we actually provide these services at a subsidy to all the universities, but it depends on how much they can afford. So the Moratua, Peradeniya, Colombo, Kalaniya would be getting higher bandwidth, while the smaller universities will be getting very small chunk of that one. So which means they are further disadvantaged as going forward. So we are looking at rather than depending on this commodity part, how can we ensure that everybody gets similar access? Because without doing that, we cannot expect to move forward. Now this comes from this is the same thinking that was that had been there in the development of what we identify as Internet 2 in the United States. If you know about Internet 2, that is basically the research network in the United States, and why they came about that one is that definitely they developed more. They were part of the development of the internet, but when you go to the commodity internet, as you understand, with the contention ratios, the access or the connectivity to do the education and the research work, you need to contend with the commodity traffic, and you don't get like a bigger highway for you to do your educational and research work, since you have to deal with all the other traffic that for entertainment and all that. So because of that, they developed this Internet 2 by working with the telecommunication companies and power companies, by leasing out the fiber connectivity to establish this type of network throughout the US. And this similar type of things are done everywhere in the world now. I mean, in Europe, you have the country-wise similar networks, and they also have connected together in the joint project. And I mean, so when we talk about this one, people are usually like, okay, this is United States and Europe. We are talking about we are not capable of doing that, but it's not so. I mean, if you look at our area, I mean, I assume you might know that in India, of course, through NKN, National Knowledge Network, they are so far ahead in this project. And Pakistan, PERN is into the third phase of their own network, and even Bangladesh, we work very closely with. They established their fiber network in 2013, about 8 years ago. So, and then in recent discussions, we also found that both NREN, the Nepal Research and Education Network, as well as Drukren from Bhutan, they are also looking at establishing their own network. So because this is why it's not just to provide equal and better quality access by having our own network, but to provide for the education and research work, which comes to the next vision that we have to reimagine our role as the National Research and Education Network. So basically, we are looking at how the world, the NRENs are working together in to what we call is connect, communicate, and collaborate. As I mentioned earlier, this is basically the 21st century skills that we are talking about. So connect, communicate, and collaborate together for global scale research work and education. So we see that these type of projects happening world over. So as Sri Lankan education sector, higher education and research, we need to play a bigger part and bigger role in this one. and provide these opportunities to our education sector so that they could be at that stage, so which we need to ensure that happens as soon as possible. So at the moment, we are of course connected to the TAIN network, Trans-Eurasia Information Network, which is in the Asian region, but we are not utilizing that to do this, the type of work that is being done there. So we want to ensure that we establish our network and also allow our higher education institutes and the students and the staff, academic to become a part of the global research and education network. So the idea is to take part of these things, like as I said, to connect, communicate, and collaborate with very different types of projects that are there, telemedicine, weather forecasting, and even cultural things, as dancing around the world, and also which to go to the next level, where we have developed a test bed of the next generation technologies to things about not just connect, collaborate and communicate and collaborate, but can we go to the next level and innovate by providing a platform to our higher education sector. So this is what we are looking at, which is we are working on, and we hope that we can achieve those things in the next few years. But we also have seen especially in the last year or so during the pandemic, that the challenge is that that we can actually we can reimagine our network and look at to how we can repurpose it to provide better opportunities. But the remaining structural inequalities, there's so many, so I'm not going to actually attempt to even address those things. I assume that you are quite aware, and of course we saw earlier even our moderator just got dropped off suddenly, right? So Professor Ragal would actually be talking about this tomorrow at in his keynote, lessons learned from COVID-19 and NREN's perspective. So tomorrow tune in for that one, so that we can see how what are the lessons that we learn, and how can we come out of this or address those things. So just to kind of quickly bring the things into the picture, if you have seen the digital quality of life index of last year, we see that unfortunately as a country we are actually performing not very well. So when it comes to the internet affordability, we are not in the lowest part, but in the second or the lower half of that one. But when it comes to the rest of the things, actually we are performing quite badly. It comes to fast, the slowest and least stable internet, we are at the top, right? So I mean, we can all discuss or argue about this, but we know this to be a reality at the moment, which especially in the education sector, by look in the teaching, we have seen this, and as I said, Professor Ragal will discuss about these things tomorrow, and we see that we are in the lowest part of these rankings in every aspect. E-infrastructure, e-security, e-governance. So all these things, we are lagging behind a lot in the world scale. So I mean, I see that that we are not doing well, but I also see that this is, I mean, there's a huge opportunity for us because what it means is that if you are doing the best possible and we are still lagging behind other areas, of course that means there's something else wrong. But there's, when you see that there are things that we can improve, it also means that we have a huge opportunity, because if we strive together, we can actually take use of this one, do well, and because we see where we can improve. I mean, if you look at those statistics, there's only ways up. So the only way that we can do it, I believe, is for us, everybody to work together. Because one of the things is, one of the things that we have experienced in the last few years is that, it seems that, especially maybe it's an island mentality or something, that it's kind of like, it's that, if you win, I lose kind of mentality, right? This is zero-sum game issue. But I mean, as we understand, it's not the thing. If you improve, if you develop, everybody can be in a win-win situation. So if you can strive together, everybody comes together, the policymakers, the telecom operators, the education sector, if you identify what our opportunity is, right, to work together, right, for a common goal, for our future, our children's future. So that, because unless we all come together as a piece of the puzzle, there's no way forward for us, right? And when we look at this one, we need to identify a common and a long-lasting goal. I mean, we come up with the national policies. I assume that is happening already, but we need to bring all this together, the national thinking, not just from the policy point of view, but the thinking point of view. I mean, we all have to work together, because there's a huge opportunity for us to move forward if you do so. And I believe that being here, it's our role and it's our responsibility. So there's a huge opportunity, and I urge you that let's try to see how we all can work together to make this a reality. So that's about it from my side. Thank you very much.
Thank you very much, Dr. Asitha, for your wonderful talk. With your talk on the future of entrance and how you learn going to find solution for that. Actually, you have added value to the LKNOG conference. So please stay here till the end of the session with us. You will have lots of questions from our audience. So the third speech on this conference is from Mr. Oshada Senanayake. Mr. Oshada Senanayake currently is the Director General of the Telecommunication Regulatory Commission of Sri Lanka, as well as the board member of the SLT-IX. Today, Mr. Oshada is going to talk about regulatory framework for a 5G and IoT-based future. Actually, I would like to warmly welcome Mr. Oshada to deliver his keynote speech.
Thank you so much, and good morning, everybody who is connected at 37th Colombo South Asian Network Cooperators Group, hosted by the LKNOG. It's an absolute privilege to be part of this forum as the head of the Telecommunication Regulatory Commission, as well as being a part of the ICT as well as the CERT. So I thought I'll elaborate a bit of and provide a bit of perspective of the future of networks and the industries that's going through exponential change based on COVID, as well as accelerated digitalization, and also the embracement of 5G and how it's going to impact the ecosystems that we are used to, how we are used to work. We all know last year with the global pandemic, overnight, we had to change the way we work, change the way we educate ourselves. And also, in fact, I think the pandemic has made changes which is going to be permanent in the future in some sorts, where some global companies have decided that they're never going to go into a full-time, a brick and mortar sort of office environment anymore. But however, I will elaborate a few specifics. Since the previous speaker, Dr. Asitha Bandaranayake, delved on a few specifics that is of interest to me as well as a regulator, I thought I will start with that and give a bit more broader perspective on that. From a Sri Lankan perspective, as we all know, today, almost the complete economy is based on the most critical infrastructure, which is the connectivity infrastructure. Now, we all agree that, of course, there are certain issues and limitations on the quality of service. But what we need to note is also that over in last April 2020, as we went into the first lockdown, there was a surge of 40% of uptake of data requirements. The demands rose by 40% just overnight. And what we need to understand is, as any other infrastructure, right, capacity planning is done on certain projections. And of course, this was not expected. But however, this is absolutely not excuse from the regulator. But I think this is something we need to work with the industry, which we are doing right now, and ensure there's very rapid deployment and expansion of this infrastructure to meet the new demands on this new norm and the new digital environment we are facing right now with this pandemic. I think we've been forced to digitalize. It has accelerated the digitalization drives of all countries. So I think it's important that I note this point. So what is the regulator doing on this? We are working in close tandem with the industry in ensuring that we rapidly increase the capacities that's required. Right now, today, in some base stations, we see even an uptake of traffic on a 30% on month. Now, I see this as a very good problem, right? It's a good problem to have, right? I should also note that the regulator has to take certain steps also to ensure that as we go along this digitalization, we don't leave behind our next generation. For example, last April, in addition to managing these capacities, on the request and the guidance of the Telecommunication Regulatory Commission, the industry, the telecommunication industry took the onus of providing complete access to the Learn network of all the state universities, which is the e-learning platform for them, as well as the TRCSL, which is the e-learning platform for the K-12. That's the grade 1 to 12 school ecosystem. All the government schools are now free of charge. So what this means is, of course, we are facing a situation of digital divide as per the other countries as well. The International Telecommunication Union has an agenda which is called the Connect 2030, which is aligned with the UNGA's Sustainable Development Goals, the 17 SDGs. And the target for 2023 globally is to ensure broadband access to 65% of all households. Now, you would wonder on this point that this is a global scenario, right? Again, I'm not giving an excuse, but I'm giving you a global perspective on the situation. The drive from the ITU is to ensure 70% of individuals, right, get access to internet of some sort or broadband by 2023. So there is a global attempt, and I'm happy to say that Sri Lanka is well aligned, and we have our own initiative, which is the Gamata Sannivedana program. Maybe the likes of you who have connected from other countries. It's called the Connect Sri Lanka project, where we are investing from perspective of our universal service obligation of providing connectivity. The TRCSL is also investing in the rural connectivity. So right now we are covering, we have taken an approach of district-wise approach on this. We've commenced work on the Ratnapura district. We moved on to Kurunegala. We are moving on to the Mathura. And our hopeful, our bold target is to ensure that 100% connectivity is provided to Sri Lanka within about 18 to 24 months. And that we are rolling out very, very diligently and on a very fast-paced manner. Just last week, I was in 2 rural areas, in Kachigala in Abilipitia, as well as in Panana in the Ratnapura district. And then 2 tower sites were opened, which we basically worked up through the government within a program. It lighted up 42 villages overnight with 4G. Just 2 weeks back, we did the same in Gassan Dalupota, that's a rural area in Kurunegala. So I think every country is going through this process, and we are also going through this process, and we are ensuring that we are going to ensure this digital divide is reduced. In terms of affordability, again, I would like to draw your attention to the International Telecommunication Union's metrics, not ours. Sri Lanka, for the last year, on the ITU benchmarking on the internet and the data rates, as well as the voice rates, we were the 29th cheapest in the world last year on the metrics of 2019 report. We were on the 10th place for the cheapest voice in the world by last year, right? I'm proud to say, with all the work done across the last year, the latest data has been released by the International Telecommunication Union on their website. We've broken through for the first time, and we are now on the top 20 for the cheapest data rates. We are on the 20th place, and that's a rank up of 9 places within just a year. I think that's very significant, because I believe it's about the steps we take. There is no overnight solution, and I absolutely agree. We have to continue to ensure that our data rates reduce. But let's not forget what we are doing also in ensuring that there's a lot of free accessibility right now that's provided, which I believe is a first in the world, where we are taking forward the concept of free education towards the digital front as well in terms of education. So I think right now, this year, based on the ITU, we are the 7th cheapest for voice services, and we are the 20th cheapest for data services, which I think is a huge achievement as a country. And of course, also as a regulator, we are continuing to make paradigm changes, and we've introduced the first round of unlimited internet packages. This was something that had to come through, which I ensured that it came through. Of course, there has to be further steps taken to improve on that offerings that we have, and I believe that's going to do so based on the natural market variables that's going to take into effect. Now, let me take the quality of service matter, right? I think this is very important. I think Dr. Asitha also elaborated on this. It is unfortunate that we only delve on the Surfshark report of the quality of life index only, right? This is just one index of many, right? Now, the quality of life index by Surfshark, I hope, I don't know whether anybody has gone into the working of that, and I challenge anybody to do that, right? What they've done is basically they've taken the metrics from the third week of April 2020. That was the peak of COVID for any country. That was the peak where Sri Lanka went into work from home, where all literal traditional organizations, including the public sector like me, went into work from home. And of course, there was a strain on the networks. But if you are going to do a sampling analysis, right? I contest that on what grounds that they look at that and put us on the last point. Are we the best in QoS? Absolutely not. Are we the worst in the world? Certainly not. And I challenge that. And I will like to draw your attention to also much more credible other metrics, such as the Ookla speed test. Out of 140 countries, we are on the 3rd percentile, right? The cable.co.uk, the broadband speed, which is accredited, out of all the countries, we are on the 72nd. GSMA itself, GSMA is the apex body for all global network providers. The GSMA Connectivity Index 2020 puts us on a rank of 105, right? Out of 170 countries. The Economist Inclusive Internet Index in 2020, right, puts us on the 54th rank out of 100 countries. Now, these are what you call proper samplings. And unfortunately, the media, as well as every entity, just basically takes up on this just one specific thing and only highlights that. I think this is, as Dr. Asitha mentioned, we need to move out of the island mentality. And I think we need to really look at the positives as well. And today, I think we won't be having this conversation if not for the internet connectivity and the infrastructure, which is, of course, continue to be improved on. If you ask me if I'm happy with the QoS, absolutely not. We have to continue to improve it, but I think it's something we all have to do together, and I think that's where we are. So coming back to the main point of the 5G and how it's going to impact, and I think looking at the South Asian Network Operators Group, I think the 5G technology is going to make a paradigm shift in the way any sort of industry vertical is going to work, whether it's going to be health, whether it's going to be agriculture, whether it's going to be the public sector, whether it's going to be how we are going to managing public services or the service provisioning for consumers. It is going to have a paradigm shift. And a lot of countries, as we know, even on the Asian region, have moved in very aggressively on that. So I'll give you a context of from a networking aspect on what are the criticalities of 5G, right? 5G has 3 major tenets that it offers, right? The 3 major tenets are pretty much, one aspect is ultra low latency, right? So this is called URLLC, ultra reliable low latency connectivity, right? Now, what does this mean, right? So as we know, I mean, since you all are from the network community, the throughputs, the lag time, the hop times are absolutely important when we move forward to an era of connectivity based on sensorial data, right? And then comes MMTC, right? The massive machine type connectivity, right? If I give a metric analysis, if you take the current LTE services on 4G, if you take a concept of sensors, utilizing sensors, the LTE technology can provide, for example, only about 60,000 device connectivities per square kilometer. Now with 5G, it can exponentially grow to 1 million devices that can connect on a square kilometer area. This is approximate projection based on 3GPP standards. And this is what is going to really accelerate the future of Internet of Things. I think Dr. Prasad was supposed to talk about IoT. I'm not too sure whether he spoke about it before me. And I think this is what's imperative, and this is what we need to take note of. So the 5G technology is going to give a lot of different opportunities that could be leveraged in terms of Internet of Things, and how we are going to look at sorting very simple and trivial issues for the public by the utilization of technology. Now, when we look at smart traffic light systems, when we look at smart city concepts, I mean, all of these are going to be data-driven approaches. And what better way to ensure that this is done by the utilization, by rather than utilizing the Internet of Things. When you look at IoT, we have different concepts. We've got the LoRaWAN, right? The concept, the long range wide area network concept. We've got the NB IoT concept that goes on a spectrum sharing concept. So all of these amalgamate to ensure that we can leapfrog in the solutions we offer. For example, specifically the network operator group, right? So the MMTC and the ultra level low latency is very important. Again, I'll give another example. 5G is going to ensure from a scenario of LTE where there's going to be a maximum throughput of about 70 gigabytes per second, Mbps per second download rates to about 300, uplink rate of 70 and a download rate of 300. And we can increase this by 5G towards 20 gigabytes per second, right? On a download and a 10 gigabytes per second on a upload, for example, right? So these are some metrics. And the turnaround time, the latency again, I mean, theoretically, we can come down to about 5 milliseconds. So for example, autonomous vehicle management systems, collision management systems can come down to a point where on a 4G network, if you are having a collision detection system that works on the throughput and the latency of 4G at 60 miles per hour, if you want to stop a car, maybe that makes a difference between life and death. On 5G, it might send back the decision within milliseconds, where you can stop the car within 2 inches versus on the 4G LTE, whether it will take a few feet. That will be the difference. It's just an example. We are talking about smart health. We're talking about remote surgeries. I think these are imperatives for developing nations like ours, where skilled expertise is quite less, and we need to ensure we utilize technology to bridge this digital divide. So from a regulatory perspective, more and more IoT devices are coming through. We need to ensure as regulatory bodies that we become an accelerator rather than an impeding point. So what have we done from a regulatory perspective? So for example, for 5G technologies in Sri Lanka, I'll give an example. We proceeded to immediately start 5G trials early as last year, 2020. And by today, on the 3.5 gigahertz band, today we have 70 plus test areas, geographical areas that's covered by 4G by multiple operators. So one of the key aspects we ensured that all operators are given an equal opportunity and providing contiguous blocks of test spectrum to ensure that everybody has equal rights. And we are looking at commercializing this spectrum towards the end of the year. So as you would know, again, if you look at the spectrum side for 5G, there are two aspects of it, the FR1 and the FR2, the frequency range 1 and 2. The frequency range 1 goes from 450 gigahertz to the 6 gigahertz point. Right now in Sri Lanka, we are utilizing the 3.5 gigahertz band for the trials. But of course, we can utilize the existing bands that is used for LTE 4G right now, and we can refarm in the future and use for 5G, such as the 1800 bands and the 2600 bands. But interestingly, the lower gigahertz bands are much more important for creating penetration towards closed areas and aspects. But it's of course essential that we look at the millimeter band waves also to ensure that we look at the larger perspective and also higher speeds. So the millimeter band range starts from the 24.25 gigahertz to 52.6 gigahertz range, which different countries take a different opinion on how we are going to allocate it, which we are going to do. But I think as we go along, it's important as a regulator that we ensure we accelerate and assist the network industry to ensure that this sort of technology is backed by the required hardware, the required security aspects, the required peripherals to ensure that there's a cohesion between the technology as well as what we have in store in terms of technology from a ground perspective. So as a regulator today, we've taken certain steps. There's new RTT rules that we've come into play. We are ensuring that we have a fast track, and we are elaborating and we are continuing to improve these systems so that we don't become impeded. You would remember there was a time where even a laptop that has to be imported had to be approved by the regulator, which is not the case today. A firewall coming in had to be approved. But what we need to understand is when there is certain modules that basically consumes aspects of spectrum, as we go on this digital journey, it's important to understand it's like managing a traffic in a road. It's going to be chaos if you don't have some sort of discipline. There's going to be spurious emission by millions of sensors, millions of spectrum emitting devices, and these going to also impact the quality of service in the future. So hence the reason that these RPT rules are there. We call it the radio and telecommunication terminal equipment rules, but these are not there to impede or enforce any restrictions, but it's there to streamline. So for example, right now, the Telecommunication Regulatory Commission of Sri Lanka is focused on ensuring for IoT devices, we are going to have a fast track. So the low power devices, we are going to ensure there's exemptions, for example, and also ensure that there's a fast track. So just yesterday, we were in consultation with the SLASCOM as well as the ICTA. We've had 3 rounds of discussion in creating a green channel for organizations, technology organizations, to ensure that they can import these devices without any impediment. There's a lot of sensors we are talking about. So we understand the turnaround time has to be very efficient to ensure time to market for you all. But we need to ensure regulatory framework as well. Of course, as we say, there's a few bad apples that basically disrupts this initiative by taking certain measures that is not conducive for the environment. So we have to understand these sort of scenarios. And also moving forward, we are currently exploring providing a spectrum test bed for IoT testing in Sri Lanka. So we are exploring right now some millimeter bands to be assigned, and also getting through the loops and holes of the legislative issues we have in terms of creating a test bed where it will encourage startups and the new breed of organizations to get into networks, to get into this IoT-based development, right? And we are going to create a conducive environment for that. So I think it's a journey where there's going to be a huge shift in the way the regulator and the communities as well as the industries have worked. I believe there has to be a huge culture change in the way it works, as it is shown by the last 1.5 years, how the regulatory body has worked with the telecommunication industry in empowering, right, certain aspects. I'll give you an example. Just last year in Sri Lanka, we had a huge situation of spectrum management, where even assigned spectrum was couldn't be used by operators due to certain litigation, right? Because of non-existence of transparent mechanisms, right? Which has been challenged, maybe some instances fairly, right? So we had to work on these things. So these are the work that goes under the water, you know, which is not seen. Now imagine a situation today in this time and day where there's a 40 to 50% increase of capacity requirements, where we wouldn't have spectrum that could be used for the operators. So I'm proud to say last year by November, we settled 15 plus litigation cases in ensuring we unlock these bottlenecks in terms of providing spectrum. We've moved over to ensure that there are certain deregularization as well, ensuring that the regulator is ahead of the curve rather than behind the curve. And these are normal phenomena, and we need to go along. So we are very happy, and I'm very happy to mention in this forum that we are willing to work with the industries. We are willing to work with the community, in this case, the network operator group. Even we are willing to have conversations and work together in looking at creating a very conducive scenario where we can accelerate the growth of Sri Lanka as well as even as today as Asia. I think we have a big role to play from a global perspective of moving forward as Asia as the next powerhouse and the epicenter of technological innovation. And I think we are well aligned to that. And I thank you again for the LKNOG and the South Asian Network Operators Group for inviting me today to this keynote. And I would like to note again that we are very open to working with you all and accelerating your initiatives. Thank you so much. All the best.
Thank you very much for the beautiful talk, Mr. Oshada. I hope everybody was benefited and will also helpful to make strategies for Sri Lankan telecommunication industry. So that's the end of keynote speeches for this session. So if you have any questions from our keynote speakers, it's time to answer.
I have a question. My name is Champika. Can I ask that now?
Yes, Ms. Champika. Yes.
Yes, actually, this question probably can maybe directed towards both speakers, Oshada as well as Dr. Prasad as well, because currently, especially when you speak about 5G as well as even IoT, there are some perceptions going on whether can non-IP solutions can be deployed in 5G, and also things like whether the IP can work in constrained devices, and also whether things like whether the TCP/IP can handle latency sensitive applications and so on. So there are kind of some perceptions whether we might need a different solution other than IP. So what I want to get your views on this, and also my sort of point is that currently IP can handle this, and also there are work going on. I mean, work is happening in IETF, especially there are some development of new protocols like Quick and so on. That can also take care of some of these functions. And also, I think some of the confusion probably due to the network slicing feature, whether that would also create some kind of more private networks as well. So just wanted to get your view on this, and how do you take it? I mean, especially with regard to these solutions, and what I think is that IP can still handle these situations quite well.
Yes. Dr. Asitha, can you comment on? Oh, yes.
Can I take that as well?
Yeah,
So,
Asitha.
thanks for that point. I believe it is a very intriguing question, right? Where we moved to a device management and service enablement capability for managing IoT devices from a cellular IoT perspective on a 5G network, right? I think there are certain major enhancements that we need to figure out from a low cost perspective and simplified devices perspective. So I think there are a few white papers that has been introduced on this by 3GPP as well, in terms of looking at IP devices in networks, and also how more specifically how non-IP devices can work on these NB-IoT platforms on the front, right? So I think this is also supported by the traditional technical aspect of UDP and SMS transport aspects and all of that. So I think that's work in progress, right? And there's quite a few white papers, and I'm happy to share with you some of that perspective as well. But this is something that has to be continued to discuss. And but there are standardizations that's coming through on this exact specific point, both from a perspective of 3GPP as well as even other certain providers like Ericsson and the other providers, the key 5G champions. There are white papers that is out there, and there are certain standardization coming into play.
Thank you.
Thank you. Yes. If we are ending with the questions, I think as we are running out of time, and so many technical sessions, 3 technical sessions lined up for today's conference, I think we can have a short break and come to our next technical session. Thank you very much for our speakers today, Dr. Prasad, Dr. Asitha, and Mr. Oshada, for sharing your experience as well as your views on Sri Lankan network, and how to look from here to future about the Sri Lankan network telecommunication industry. Thank you very much. So we will meet everyone again after a short break. We will have 15-minute short break. See you all in our next technical session. Thank you. Hello, everyone. Welcome you all again after a short break to LKNOG5 conference. LKNOG5 conference is in collaboration with SANOG 37. Our sponsors are Learn, Ethnic, AWS, and Apricot. So it's time to start the technical sessions. This is the first technical session of our conference. The presentation for this session is from Mr. Ron Bonica, is on IP Flexalgo. Ron Bonica is a distinguished engineer in Juniper Networks routing protocols group, specializing in IPv6 and segment routing. Ron?
Yes.
Are you there? Yes.
Yes.
Yes. Thank you for joining. We warmly welcome to the conference, and it's time for you.
Well, thank you very much. I'll share my screen.
Yeah.
And
Yes.
go to
We can see the
show mode.
Yes.
Okay, can you see it now?
Yeah, perfect.
Okay. I'd like to talk to you a little bit today about a new IP routing feature called IP Flexalgo. And it is a traffic engineering mechanism. It allows you to to let some traffic traverse a path other than the least cost path. Now, in our experience, we found that there are basically three kinds of network operators. There are network operators who require coarse-grained traffic engineering. Every one of their paths needs to be traffic engineered with a different policy and a different set of rules. For that set of customers, IP Flexalgo will not help you. For that set of customers, you need segment routing TE, you need RSVP TE, you need something that gives you coarse-grained control. Then there's a middle set. The middle set needs, I'm sorry, fine-grained control is RSVP TE, SRTE. Then there's the middle set that needs coarse-grained control. Most of their traffic might travel the least cost path, or maybe there are 2 or 3 or maybe even 6 policies network-wide. For them, IP Flexalgo is a good solution. It doesn't require encapsulation of any kind. It doesn't require MPLS. It doesn't require SR. It doesn't require IPv6 routing headers. It will work in any IP network, an IPv6 network, an IPv4 network. And then the third kind of operator requires no traffic engineering at all. All of its traffic can follow the least cost path. That class of operator clearly doesn't need Flexalgo. So we're talking to that middle class of operator that needs coarse-grained traffic engineering. And we'll give some examples of what that is in a minute. So our agenda here is I'll show you an abstract use case. I'll show you how IP Flexalgo works. And then I'll show you 3, I call them enterprise, but they're really concrete use cases that could show up in the enterprise or in the WAN. And then we'll draw some conclusions. So here is an abstract use case. You have a network with exactly 4 traffic policies. One is for red flows. They traverse red links and no others. So you'll see 2 red links and a smaller red line that is the only path a red flow can take from R1 to R4. Then we have orange flows that prefer red links, but they can fail over to blue links when a red link is gone. Then we have blue flows that can only traverse blue links, and yellow flows that prefer blue links, but they can fail over to red in case of network outages. So let's talk about how this Flexalgo works. How would we make these policies enforceable without RSVP-TE or without SR or any of the more heavyweight traffic engineering mechanisms? Well, the first thing we're going to do is make some link advertisements. And these link they refer to the topology we saw 2 slides back. Every link can be given 2 metrics, an IGP metric and a TE metric. And it can also be given an administrative group. So what we're going to do is give metrics of either 200 or 400 to every link. We're also going to give a color to every link. So if we go back a couple slides, you'll see there are red links, there are blue links, and every link will have 2 different metrics, either 200 or 400, depending on whether it's the TE or administrative group. Then the next thing we're going to do is define 4 Flexalgos, 1 for each policy. And the Flexalgo basically has 3 pieces of information in it. Which metric does it use? Either IGP or TE. They all use the same calculation type, shortest path first. And they all have some constraints. Their constraint can be either exclude blue, include all, or exclude red. Now, with these 3 different Flexalgos, we can build 3 different views of the link state database. And you'll see that in just a bit. We're going to pull it all together here. Here is our network, and we're going to build paths from R1 to R4. The first thing we have to do is to configure 4 different loopbacks on R4. Each loopback has a different IP address. You'll see that in the figure. And each loopback is associated with a different Flexalgo. Loopback A is with the red FAD or the red Flexalgo. Loopback B with orange, C with blue, D with yellow. Now, R1 will calculate the least cost path to R4 4 times, once using each FAD/prefix. So let's say the first time, it will calculate the least cost path to R4, but the only loopback on R4 that it will see is the red loopback. It won't see the orange, yellow, or blue loopbacks because they are not in that FAD. It will use the metrics that the red FAD uses. I think they were IGP metrics, and it will include only the red links because the red FAD excludes all links other than red. So what routes are we going to have from R1 to R4? Well, the route via prefix A, the red loopback, the next hop will be R2. There will be no failover because the red FAD excludes all blue links. If you're going from R1 to R4, the only way to get there is through R2 because the red FAD just ignores links R1, R3, and R3, R4. Now, let's do the same for routes from R1 to R4 over the orange to prefix B, that is the orange FAD. The next hop is R2 because the orange FAD uses IGP metrics. So the shortest path is through R2. And there is a failover through R3 because the orange FAD includes all links. And it just happens that the metric through R2 is lower, it's higher through R3. So if the path through R2 fails, you'll fail over to the path through R3. We continue this time for prefix segment C, that is the blue loopback. Next hop is through R3. There's no failover because the blue FAD excludes red links. And finally, we do the same thing for D yellow. That is to the yellow loopback on R4. Next hop is through R3 because the FAD uses TE metrics and the lower metric is through the blue links. there is a failover through R2 because the yellow FAD includes all links. Now, why would you go towards IP Flexalgo? Well, it works in a plain old IPv4 network. It works in a plain old IPv6 network. There's no need for MPLS encapsulation or encapsulation of any kind. No need for SRv6. You could use this Flexalgo engineered network as an underlay, or you could use it without an underlay at all if you don't need one. You do have multiple loopbacks on each node, one associated with each Flexalgo, and you're using FAD procedures that are actually reused from SR, from draft LSR Flexalgo, and the computation procedures from that same draft. Loopbacks corresponding to Flexalgo follow a specific path, and the next hop for each loopback is computed based on the Flexalgo. So what exactly does that mean? Let's say you have, going back to the figure, a BGP route on R1 whose next hop is the yellow interface on R4. It will follow the yellow path. So Flexalgo works even for indirect routes, say a BGP route whose next hop is a loopback associated with a FAD. And following up on that, service prefixes carry different loopbacks as protocol next hops. So you can use IP and IP tunnel to carrying services. Let's say for a minute, you have a L3 VPN or an EVPN. You can use IP and IP encapsulation, and the bottom layer, the IP encapsulation, can be traffic engineered using IP Flexalgo. So let's talk about 3 concrete applications that can use Flexalgo. Well, this is the most common one, link bandwidth. High bandwidth flows, red, have to traverse high bandwidth links, red. So a high bandwidth flow has to avoid link R1, the direct link from R1 to R4. Low bandwidth links, blue, prefer the low bandwidth flows prefer low bandwidth links, but they can fail over to red. So let's say you have a low bandwidth flow from R1 to R4. It prefers the direct path, but if the direct path is gone, it can fail over. That's the difference between the red and blue. Blue can fail over to a red link, but red cannot fail over to a blue link. And this is the classic application for Flexalgo. It's where we see it used most. Another is intrusion detection. Suspicious flows, red, must visit the intrusion detection devices on R2 or R4 or be dropped. Routine flows, blue, prefer the direct link from R1 to R4, but they can fail over to the paths that visit R2 and R4 if the direct link from R1 and R4 are gone. I'm sorry, that should be they can fail over to the paths that visit R2 and R3, but they can fail over to the direct path if necessary. And finally, we have a quality of security application. Classified flows, sensitive flows, must traverse MACsec encrypted links, red, and no others. Unclassified or routine flows, blue, prefer unclassified links because they're cheaper, but they can fail over to classified ones. So, what conclusions do we draw from this? Well, Flexalgo is powerful. Many networks only require this kind of coarse-grained TE that you just saw in these 3 examples. And the benefits of using this over a fine-grained technique, you don't need MPLS, you don't need to allocate any great big address blocks, and you don't need any new protocols. All of this is built into your IGP, Most of it is there already. And it's easy to operate, no tunnels, no encapsulation. It even works for a plain old IPv4 network. It's using the plain old IP fib, so there are no great debugging procedures to learn. And multiple instances of a link state database are familiar constructs. They've been around for a while. As for readiness, you can contact your Juniper representative to get a code version. General availability is planned for later next year. Also, this will be demonstrated at EANTC later this month with some other vendors. Not quite sure what the list of vendors is. With that, I'll wrap up, and I'm not sure if questions are right now or if they come at the end of the session.
Yes. Thank you, Ron. Actually, this is the only presentation we have in this session. So it's time to, if you want to ask any questions from Ron, you can answer. Actually, thank you, Ron. You have done different lots of publications regarding to this Flexalgo. Yes, actually, we benefited from that. Yeah. Any questions related to Flexalgo, IP routing?
Hi, Ron. I have a few clarifications. So, how about the platform readiness? I mean, it's Juniper, Cisco, and all the OEMs are supporting this.
I can't speak for other vendors. From Juniper, you can get experimental code right now, and if you talk to your SE, you'll get a date for general release code. But you can get a copy to put in the lab and experiment with now. We will be demonstrating at interoperability at EANTC later this month. And if you could take a look at the EANTC report, see who else has demonstrated interoperability. You might want to go to those other vendors or and see if experimental versions are available from them.
Okay. So are there any RFCs related?
Yes, there is. It is draft IETF LSR IP Flexalgo.
Okay. Yeah, okay, Ron. I think so it will have a valuable opening. So we'll check and go through the slides and the information which you provide. So that will be helpful for us.
Okay. And if there's a way I can send a link to the internet draft and even the EANTC report when it's out, is there a way that I can do that?
Yeah, of course.
Okay.
Okay, thank you very much.
Any questions? Any other questions? Actually, we will link Ron's LinkedIn profile to our LKNOG website. So from that, you can contact Ron for more clarifications. Yes. Tilina?
Yeah, Jivan. So if there's no any other questions, we can break for lunch. And then we can start again at 1 p.m. with the other sessions.
Yes.
1 p.m. Sri Lanka time.
Yes. So actually we have another 2 more technical sessions. So we will have the lunch break from now. So we will meet again at 12:30, 1 o'clock, right?
Yeah, 1 o'clock.
Yeah, 1 o'clock from Sri Lankan time. Thank you very much, Ran, for your interesting presentation, and to all who have participated, please join with us in our next technical session also.
Thank you.
Thank you.
Hi, good afternoon all. I believe I am audible.
Yes, Subha, go ahead.
Okay. Hi, good afternoon all. Welcome back to the LKNOG5 session after the lunch break. We have another great 4 technical sessions available to you. Please stay with us. So the next session is BGP based current practices, and the session conducted by Dr. Philip Smith. He has been working in the internet industry since early 1990s. And now he is attached to a network startup resource center as a senior network engineer and trainer. He has a lot of training experiences along with APNIC, NOGs, and also Apricot. Hope it will be a great learning session for you. If you have any questions during the session, you can post in the chat, or you can ask directly from the speaker after this session. So, Dr. Philip Smith, the screen is for you.
All right, thank you. Let me just try and do this. Nope, wrong one. Let me try that one, and this one, and here, and there. That should work. All right, so hopefully you can hear me all okay. So just discussing with Thelina and so on about how to try and do this. So this is basically a 2-hour presentation, which I would normally cover as part of training courses and so forth. But what I've tried to do here is condense it into the 30 minutes that are available in my portion of this session. So I just want to try and share some of the highlights around BGP best current practices, or maybe BGP good practices, or whatever we want to call them. So just before we start, I mean, I know this has been recorded and it's also webcast live, but a lot of folks always want to have a look and see, you know, for a lot of other content around BGP. So as I say, this is part of a much bigger presentation. It's has been recorded by the Network Startup Resource Center last year. So if you want to see it again in all its glory, you feel free to go and have a look at this site. So what I really want to try and do is make sure that BGP is configured optimally, operating optimally, configured securely, and operating securely. So I'll try, this is not going to be an exhaustive presentation for the next 30 minutes, but I'm going to try and pick out some of the main pieces that you want to be aware of. You know, I suppose the first piece is looking at what BGP is used for versus what the interior protocols, so OSPF and ISIS, are used for. The latter, OSPF and ISIS, are used just to carry your infrastructure reachability prefixes so that the routers can find each other inside your network. Everything else goes into BGP. So BGP runs across your network as IBGP, carrying internet prefixes across the backbone if you want to do that. And that's where you put all your customer prefixes as well. And then there's external BGP, which is how your autonomous system speaks to other people's autonomous systems. So we're exchanging prefixes with those. And it's also where you implement your routing policy. So that's a fairly high level of what these different protocols are used for. Now, the eBGP default behavior. What happened there? Yes, slide jumped over. The default behavior. So industry standard is described in RFC 8212. And what this is trying to do is explain how external BGP should behave in the absence of any policies. Yes, it's a very big RFC number, which means it's come out fairly recently. It would have been kind of useful to have this 30 years ago, because it would have helped with some of the issues we see on the internet and have seen for the last 25 years or so. But anyway, it means configuring, you have to set inbound and outbound policy for eBGP to function with a neighbor. If you miss out any filters, then it means everything that your router and your network knows gets passed on to eBGP peer, and everything that they know gets accepted by you. And that can be pretty disastrous. And the RFC actually talks about some of the situations. Just a couple of cases. Free range routing turns on that RFC 8212 support by default. If you have a look there in the command line snapshot, you just see the eBGP requires policy command line, and that it's actually there by default. You can turn it off if you're crazy, but I would recommend that you keep that active there. Oops. Getting all these Zoom notifications, which is why my screen is jumping along. Cisco IOS XE, at least the latest one I've been playing with, 17.3, seems to have this safe eBGP policy, which does exactly the same thing. Next bit, one of my favorite things, as some of you will know, that I've been sort of chasing for, well, probably for the last 22 years. Aggregation means announcing the address block received from the registry to other autonomous systems connected to your network. Sub-prefixes can be announced. They can be used internally in your network, obviously, because your customers are using these sub-prefixes, and they can be announced to other autonomous systems to help with multi-homing. But these days, and it has been probably for the last 15, 20 years, everybody's thinking of Class Cs for IPv4. And if you look at the v4 table, those numbers I just summarized the other day, almost 500,000/24s in a v4 table of 860,000 prefixes. And the thing is, you can get rid of most of those /24s and you still have perfect connectivity to the global internet. And just in case you think v6 is perfect, it is not. Exactly the same thing is happening in v6. People are taking the /32 address blocks that they get from the registries, APNIC in this case, and chopping them up into very small pieces, mostly 48s. More than, actually it's not quite, but it's getting almost half of the v6 table is made up of these /48s. These are not direct delegations by APNIC. These are operators who are chopping up their /32s. Deaggregation is happening in Sri Lanka. I don't mean to embarrass anybody and so forth, but I just picked out the top 5. And so here a list. We look at the number of networks these 5 networks, well, 5 operators are announcing. The savings column shows how many prefixes can actually be saved if they actually did any aggregating. So, 60 prefixes being announced, 57 savings possible. It's like, well, why are 3 not being announced instead of the 60? Now, I know traffic engineering is needed, but you don't traffic engineer by taking 60 prefixes and dividing them up into tiny little pieces. You take your big aggregate and you divide it into 2 or 3 or 4 pieces to do your traffic engineering. So work can be done here, and I'll be talking more about this tomorrow at the SANOG conference itself. Now, for receiving prefixes, 3 scenarios, basically from your customer talking BGP to you, from your peer talking BGP to you, and your upstream or transit provider talking BGP to you. And each one has different filtering requirements, and you need to treat them differently from each other. For example, from your customers, first off, check that your customer has actually got the address space that they're entitled to announce to you. Only accept that. Don't accept any old anything coming from them. If you're not sure, look up the database. The 5 regional registry databases list who the address space has been signed to. If you don't want to traipse around the 5 registries, APNIC has a nice JWhois service there at the command line. It's the joint whois, and that queries all 5 registry databases. Look it up. Don't just rely on a letter of authority from the customer. Anybody can write letter of authorities pretending to be anybody else. They are not worth the paper they're written on. Check the authoritative database that these people really can announce that address space to you. Prefixes from peers. Well, again, a peer is an operator. You basically agree to swap prefixes that you originate. Your address space you originate, you send it announcements to them. They originate address space from them and their customers. They send it to you. This is usually all documented in a peering agreement. So make sure that the filters match what the peering agreement says. Now, some people, they just update each other by email. That's probably good enough. Others will use the Internet Routing Registry, and then they will use configuration tools like the IRR toolset, which is pretty old, BGP Q3 and so forth, which will build router configurations from what is contained in Internet Routing Registry. What else? Transit providers. Well, these are the folks you pay to give you transit to the whole Internet. So do you really want to receive all the prefixes I mentioned a few slides ago? The whole, what is it, 800 and almost 60,000 V4, the 125,000 V6? Well, I suppose if you're providing transit to other autonomous systems and these people need to do traffic engineering, then they'll need a substantial amount of prefixes from you to be able to load balance between you and their other upstream. But if you're at the end, and that's the vast majority of autonomous systems and internet, you're the one who's doing multi-homing. You don't have any end autonomous systems connected to you. So in that case, get your transit provider to send your default route or send you a full table, and then you just discard what you don't need for your traffic engineering. It's much easier than trying to carry vast amount of prefixes just for connectivity. Also, be careful what you're accepting. Don't accept the default route unless you need it. From time to time, random places around the internet randomly announce the default route. And it doesn't really cause you a huge amount of issues unless you're trying to use it for internal purposes. but can be issue for your connectivity or connectivity, especially for them. Obviously, don't accept your own prefixes. You will not normally see your prefixes coming from any other provider. That's usually a configuration mistake. Be careful with the special use prefixes for v4 and v6. RFC 6890 documents those. A lot of people are filtering v4 prefixes longer than the 24. That's the historical class C. Even though class Cs were obsoleted in 1994, as I said earlier, operators still seem to love the 24s. And of course, the IPv6 48 is going exactly the same way. Don't accept unassigned prefixes. There are a huge amount of unassigned prefixes sitting out there that are being used by lots of different entities around the planet. Why are these being used? Well, people are looking around for unused address space and happily sitting on it. It's not a tiny little problem, as some people try to claim. There are vast amounts of prefixes that are not in the registry databases. So, and they are being used by various folks in various places. Team Cymru do a wonderful Bogon route server. So if you don't really want to sign up, well, at least check all the lists of what's used and what's not used, use their route server, which makes it nice and simple for you. And they'll be talking more at the SANOG plenary tomorrow. What else? The peering database. Anybody who's running an autonomous system, please put yourself in the peering database. I would have loved to put Sri Lankan examples in here, but they were too embarrassing to put up. So I've used Facebook's one instead, because it's a good example of the type of thing you should put in. I was going to use some Sri Lankan ones, but they basically have nothing in them at all. No useful information, nothing that would make me as a potential peer want to peer with any of the operators. So if you have an autonomous system, put details in it, and that tells other operators what you are, what you have, and improves your peerability and interconnections. Internet routing registry. Some of you will be aware that some operators require you to be registered in the Internet Routing Registry before they'll basically announce your prefixes or accept your prefixes. There are many instances operating, making up the global IRR. But most commonly those are hosted by the registries, so the 5 regional registries, the RADB, and some of the major transit providers. So best practice today is for any AS holder to document the routing policy in the IRR. Route object is the absolute minimum. The route object basically has the prefix and the autonomous system number that's originating it. What we're finding more and more in the last few years, some network operators now using RPKI and ROAS to securely indicate the origin AS of their routes. So that's taking priority over the IRR entries. The downside with Internet Routing Registry, for those of us who've used it for years, is that it contains a lot of outdated and unmaintained information. People get excited about, oh, Philip's talked about the IRR, we'll set something up, and then nothing more ever. So if you're going to use these databases to register things, it needs to go in your standard operational practices for your network. So then the next question is, well, which one do I use? Well, members of our regional internet registry are recommended to use the one that they are actually running. That's part of the registry services. Operators who don't belong to any regional internet registry will generally use the upstream provider's routing registry, if they have one, or the RADB. Just note that the RADB requires an annual subscription fee to put anything in there. So that's really what to do. So it's quite simple. Registry member, use the regional internet registry one, otherwise your upstream provider or the RADB. I'm not going to talk about route origin authorization. You've probably heard this endlessly and more from APNIC and the manners folks and so forth. And so I promised I wouldn't talk about it, but the one slide summary is this. If you've never ever heard of this, then well, you can have a look at the presentation. I've got the link below. Check APNIC website, check the manners website, which I'll mention at the end of this deck. Right, let's have a look at some of the configuration tips. So this is getting really back into the nuts and bolts of BGP rather than the higher level good practices. So BGP speaker will announce the external network to iBGP peers using the router's local address, so the loopback generally, as the next hop. This saves you carrying external next hops around in your backbone. What I see happen so often is that people keep these external next hops, then they've got to carry them around in the OSPF or ISIs. So then you end up having one prefix for every single external link on your network, which for a small provider probably doesn't matter very much. But when you've got tens of thousands of customers, whether they're static or BGP customers, you end up having a huge IGP. A huge IGP means that it converges very, very slowly and your network doesn't scale. So you want your IGP to be tiny, as I said at the start, just carrying your point-to-point links within your backbone and your loopbacks. So as I say, I mean, most operators I know consider this a best practice, and it has been certainly all of this century. BGP communities. So BGP communities are hugely useful for scaling policy within your network and doing policy with your neighboring autonomous systems. If you're not using communities within your network, then you've really got something that's quite hard to manage as it grows. But be careful with the various community behaviors. So for internal BGP, propagate communities everywhere, right? For internal. Just be aware, some vendors have this turned off by default. And use communities for internal BGP scaling. This whole day of trying to do prefix filtering and all other types of filtering in your internal BGP between different points of presence, that's just crazy trying to even maintain that. Use BGP communities, you can tag different services and different destinations and make the network more manageable internally. For eBGP, so external, only send communities to influence your BGP peers' policies. Don't just send any old thing that you have. I mean, so often, especially if you look at route views at the University of Oregon, you can see some of the peers there, and they've got screens of communities, a lot of ones that are simply internal use only. Also, don't send communities that you've learned from other operators. There have been, over the years, we've seen a few presentations from various folks showing how they can take advantage, let us say, of these communities that their upstream providers passed on from other providers. So communities are really intended for local network scaling and for policy in between you and your direct eBGP peer. And likewise, for accepting communities, only accept those that you need to influence your BGP policies. Otherwise, remove them or just overwrite them with something internal. Also, be aware that each vendor has a different policy language behaviors for how they treat well-known communities, how they set communities, how they remove communities, and how they replace communities. RFC 8651 was put together because of this. And certainly these days, we've got so many different vendors playing in the global internet infrastructure space. We've got, not only do we have the hardware vendors with the BGP implementations, we've got implementations like FRR I mentioned before. Everybody does something slightly different with communities. So rather than just assuming that vendor A does the same as vendor B and the same as vendor C, you have to check really how they handle these. So there's a lot of accidents and incidents that happened over the years because of assumptions. Never assume anything. Now, what else? Limiting the AS path length. This is a fun one. For me, who spent years watching the BGP table, you get some amazing examples of AS path lengths. Well, the first one is from a long time ago. This is from the days that the 6-bone still existed. And that was an error in a V6 implementation. So it's long, the internet is not that deep. But the next one was more fun because that was actually relatively recent, probably a few years ago now. 100 prepends of AS5404. And you look at there, if you know the Cisco syntax, the greater than sign there means best path. So what are they doing exactly? Nobody knows. Even to this day, the owner of that address space claimed that it wasn't him. So I don't know. It looks like 5404. So not sure what's going on. Private ASs. Private documentation, unsigned ASNs must be removed from announcements to the public internet. So you can't just rely on the, oh, Cisco's got this remove private AS command. There's a whole raft of ASs that should not be used. Not only do we have 0.65535, I've got all these other ones mentioned in the table here. You should not be seeing any of these in the global internet. And as I'll show you tomorrow, guess what? We see these in the global internet because operators are not filtering them. Maximum prefix tracking. Yes, this is always a usual thing. A lot of routers these days have reduced fib sizes, so forwarding table sizes. And some people get a shock when filters don't work as they expect, or their upstream provider suddenly sends them 800,000 prefixes rather than the 2,000 they were expecting. So if you know how many prefixes you're going to get from a neighbor, then set maximum prefixes to be double that. That will allow for the daily up and down ebb and flow of the global BGP table, especially from a peer. But when they suddenly send you the full table when you're only expecting a few prefixes, then you don't end up breaking your network badly. The router will warn you, and then it will shut down the BGP session if you want, if the limit is exceeded. Even if you're receiving the full table, it's still a good idea to set a limit. We've seen times in recent years and years gone by where the BGP table, global table, has got 50% bigger. So this again will prevent against major accidental leaks. The TTL hack. It's amazing how few people have even heard of this, and it's been around since, what, 2003? I think it was Dave Meyer talked about this at one of the NANOGs. RFC 5082, the generalized TTL security mechanism. Now, you know what the time to live is. Router 2 setting up BGP or router 1, normally router 2 would set up TTL as 1, which means that router 1 sees it as 0, which means it's a direct connection. But that means an attacker can come in and in this diagram, they could set TTL to 2 and then try and attack the BGP session on R1 because TTL will be 0 as well. They've got to guess a few other things, but people seem quite capable of doing that. So if we set the TTL to be 255 instead on R2, R1 sees TTL 254. An attacker can't set 256 because 255 is the biggest number. And so this way we prevent an attacker attacking the BGP session directly. I see some operators doing it, and I see a lot of others, when I mention GTSM, they go, what? Or BTSH, which is what I was half about to say. So this is another way of protecting the BGP session. Templates, another favorite. Good practice to configure templates for everything. I mean, these days, we've seen tutorials earlier in the week about network management and so forth. Configuration management is the same thing. The days of people logging into routers and doing custom configuration for particular customers or peers are really gone. You need to template everything. Furthermore, vendor defaults tend not to be very optimal or very useful for, commercial or even, research and education network operators. So build your own defaults that suit your network operation. And I've got examples to put in the templates here. I've mentioned Team Cymru before. I mean, we put together these templates way back, goodness, when we started doing those, 2001, 2002, and they've listed some very comprehensive templates there. So things I've mentioned before, IBGP between loopbacks, the next hop self I've mentioned to keep the demarcation and external point-to-points out of IGP. Always send communities an IBGP, otherwise you're going to get policy accidents. Hardwire BGP to version 4, believe it or not, some people will try BGP version 3 on old kit, and that does interesting things to some particular routers as well. So just make sure you got that version 4 in there. Passwords in the IBGP session. Some people say that's being very paranoid. I don't think it is. It's useful to put in there. It's a shared secret. It doesn't kill the CPU on the router anymore. It It might have done in the 1990s, but that was long fixed 20 years ago. If the arriving packets don't have the correct MD5 hash, they are ignored. And this will defeat miscreants who are trying to attack BGP sessions. Very useful if you put this one in with GTSM, I mentioned earlier. eBGP template, BGP dampening, don't do it, just don't do it. This was a solution for a problem that we had in 1996, 1997 internet. It went away in 1998. Researchers saw there were big problems with flat damping in 2001, 2002. There are still operators today who will turn on flat damping. So just don't do it. There's an RFC that describes what you should do if you really, really, really want to do it, and you don't want to do it. Remove private unassigned autonomous systems. I mentioned before, I've talked about RFC 8212. So just get your BGP default requiring inbound and outbound policies. Make sure that always filters on the BGP session, and also the password agreed with your eBGP peer. In fact, some operators will not peer with you unless there's a password set up on the session. What else? Maximum prefix tracking I mentioned, put that in the template. Limit the AS path length I've talked about. Logging is good and keep monitoring those logs. The BGP administrative distance, some vendors have the BGP admin distance lower than that of OSPF or ISIs. Bad idea, because then if somebody sends your prefixes from outside and you don't have a filter for them, BGP wins, not OSPF ISIs. And well, if you've ever been part of a network where that has happened, you will learn very quickly that you need the BGP admin distance bigger than that of any IGP. Routing security. Others have talked about manners. I'm sure it's been talked about in Sri Lanka for the last year or two when the manners ambassadors are out and about spreading the word. Just goes without saying, you know, even though manners is a relatively new initiative, there's actually nothing new in what it's about. It's things that have been around since the late 1990s. Filtering, I mean, filtering is not new. BCP 38 is not new either. 2001, that first became in general use. I've talked about route objects. I've talked about peering DB. Make sure you know how to speak to other people's NOCs. Other people have talked about route origin authorization. So do I need to say more about that? And otherwise, that is all I have at very high speed. So I hope it was all understandable and so forth. And if there are any questions, happy to have those now. Otherwise, feel free to send me email at the email address at the head of the presentation as well. Seems like there are no questions, so back to Subhashini.
It seems no questions now. So if anyone has any questions, we'll publish your profile and Dr. Smith in our website so they can reach you also. And thank you very much for your valuable contribution to the LKNOG5 event. Yeah, we'll move to our next session. Our next session is about encrypted DNS. So Champika from ICANN, he will be conducting the session for you. And Champika works for ICANN as Technical Engagement Manager for Asia Pacific region. He was instrumental in forming LKNOG and served as a founder president of LKNOG. He is the main pillar of success story of LKNOG and a very good trainer and speaker who contributes a lot in APNIC, ICANN and Apricot events. I believe it will be a great technical session on encrypted DNS. Mr. Champika, this screen is for you.
Yeah, thank you. Thanks, Siva, for that introduction. Let me try to share my slides. Hope you can see that now.
Yes, Champika, can see.
Yes, yeah, and welcome everyone. So good afternoon, good evening, wherever you are joining from. So in this session, as it was told, I will be covering mainly on encrypted DNS. So I'm pretty sure, because I'm assuming that because given that you are network operators and so on, you know pretty much about the DNS and how it works. But just in case, if there is anyone who is new to DNS, this is just a kind of quick recap. You can see that. I hope you can see my mouse pointer here. You can see the clients, or what we call the stub resolve or the stub client, and then the query goes from client to the recursive servers or recursive resolvers, typically operated by network operators like yourself, the mobile operators and so on, or public DNS service providers and so on, right? And then there could be many other forwarders, caching forwarders and so on, but I've just kind of put the whole cloud here because there could be many of the intermediate servers in between. And then the queries would go and end up in authoritative servers. So these authoritative servers could be things like root servers or top level domain servers, next level or second level domain servers and so on. So these are all authoritative servers. Now, the important thing, and obviously these recursive servers would then talk to these authoritative servers, find the answers and return back to the clients. Now, when you see these queries and responses, the important thing what you need to notice here, you can see in these gray arrows that I have highlighted, all these responses and messages, basically they are unencrypted. So the communication is all unencrypted, right? So all the way the message goes out from the client to the recursive resolvers and to the authoritative servers, coming back, sending back to the client. It's all unencrypted. So which means it's a clear text message. Now, the thing is, I mean, this is the way that DNS has been there for so long. I mean, since early 1980s, where the initial RFCs were published. And, basically by the protocol design itself, some of these things like, the confidentiality aspect, then the authenticity aspect, then the integrity aspect, these were not really handled by the protocol. So that is why later on, if you want to add these security mechanisms, we had to add those separately. So this is something that you will need to understand. Now, sometimes when we say encrypted DNS, a lot of people also get confused with DNSSEC, or simply we say DNS security extensions. So in DNSSEC, we really don't talk about encrypted DNS, because encryption is not something in the context of in DNSSEC, right? So in DNSSEC, we are not talking about the encryption stuff. In fact, we are not talking about handling confidentiality or privacy related to that. In DNSSEC, what we are trying to handle is things like authenticity. Authenticity is that if I send you a response, DNS response, whether you are really getting it from me, okay? So it's really coming from me. So that is what we call authenticity. And then the other thing is the integrity. That is also handled by DNSSEC. Integrity is that when I send you something, it is not, you get the assurance that it is not modified in the middle. So the data, the information is not modified, and the integrity is preserved. So what I send, you get it. So that's the integrity part. So these are the two things that handled by DNSSEC, the authenticity and integrity. But DNSSEC doesn't handle the confidentiality aspect. So when I say confidentiality, you can also call it as privacy, for example. Why I'm trying to say privacy, I told you that these are all unencrypted communication. clear text messages. So for example, if someone is monitoring, it could be even in the middle, or it could be even these recursive servers, right? So these recursive server operators, they know exactly, I think someone is, someone's mic is not muted. All right, okay, let me start again. So I was just trying to say that the unencrypted communication, right? So that happens. So if someone is monitoring this in the middle, or if someone, even these recursive server operators and so on, they can see where these queries are going. Basically, they can see all the metadata related to these queries. So this is a privacy issue, right? This is a confidentiality related issue. So this is why, especially in the recent times, the community, the technical community, IETF, they have been working on some of these protocols that could help in doing this DNS encryption, right? So that's the whole scope here, scope for this discussion. Now, also the other thing now, with regard to that previous slide I was showing you earlier, in normal DNS, everything was all unencrypted, but when it comes to DNS encryption or encrypted DNS, our focus is actually between the stub resolver or the stub client and the recursive server, right? We are not talking beyond that. I mean, there are some currently work going on that, but it's not, there are no, I mean, it's not standards as such. So our focus here at the moment, the protocols that we are talking about at the moment, is between the stub resolver and the recursive servers or recursive resolvers. So basically, pretty much based between the client and the resolver, generally operated by the ISP or mobile operators, or those public DNS servers operated by the public DNS service providers, right? Or it could be even corporate sometimes. So that's our context for this discussion. Okay, now I think I have already explained this, where this encryption is happening, right? So encryption is happening between the stub resolver and the recursive resolver, but that is very important, right? So you might wonder, okay, why we are not doing all that? But between those 2 points, between the stub resolver and the recursive resolver, it is quite important, because all that metadata that we are talking about and so on, this can be captured between these, right? And then until recently, all these, most of these stub resolvers, they appear in different, for example, like typically if you consider the applications, they would call the stub resolvers that are in the operating system, right? So stub resolver is running in the operating system. So the applications would call for the sub resolvers in the operating system, and that is the one which is doing the query. But in more recent times, we have seen now this stub resolver function is brought into the applications, right? So just to repeat that, previously, we used to run the stub resolver in the operating system, and the applications would call for that, stub resolver for the DNS resolution, and then the stub resolver would go and talk to the recursive resolvers. But now we are talking about having those stub resolvers in the applications. Say, for example, even browsers. Browser is an application. So especially in the last few years, we have seen now the browser vendors and so on, they add their own stub resolvers into their browsers and the applications and so on. Okay, so that's something to note, especially in regards to the DNS encryption. All right, now earlier I told you that there are some protocols related to this. So let's see, what are these protocols? Now, if the whole purpose is the encryption, right? So if we want to do encryption, best way is yeah, you do it over TLS basically, right? Because in that layer we can do the encryption. So that is why this protocol called DNS over TLS came. This was about 5 years ago. So if we want to have that DNS privacy, if we want to have that confidentiality, DOT is an option, right? So we can have all those DNS queries over TLS, right? And this is simply called DOT, to stand for DNS over TLS. Now, if you want to go and further read about this, there is an IETF draft, and there is a link for that. If you look for RFC 7858, that talks about DNS over TLS, or simply DOT. And then another option was, which actually came a few years or a couple of years after the DOT, that is actually DNS over HTTPS. This is what we call DOH, or simply called DO or DOH, right? So these two protocols are the ones that we are going to discuss and then see the implications. There are some other, non-standard protocols and so on in relation to the encryption, but they have only very small deployment. So our focus here is actually DOT and DOH, right? Okay, now from DNS over TLS point of view, right? DOT point of view, what we are trying to do is basically to get the advantage of the TLS, right, or the transport layer security, and then send the encrypted information. Okay, and by doing this, we can also actually authenticate the users as well, right, and also actually achieve that confidentiality factor, right, in terms of the DNS queries. Now, one more thing you need to note here. Now, this is when you speak of DOT, it is actually running on TCP on port 853. The normal DNS queries, we run UDP over port 53, right? Port 53 UDP. And but if you are speaking of DOT, it is over TCP, and we are using a very specific port for that, and that is port 853, right? Now, because we are using this, we are taking the advantage of TLS. We can also use quite a lot of applications with this. For example, we can use emails, we can use mobile applications, and so on. I mean, anything that uses TLS can be used here, right? And also, actually, even from operators' point of view, say for example, you are ISP, you are a mobile operator, right? You could be applying various policies or filtering based on certain local policies that you are applying. Say for example, depending on your local policy, you could be filtering some DNS traffic, right? You could still do this because in this case, there is a specific port, right? Port 853, so you can still do that. So this doesn't really make much of an impact in terms of a network operator or ISP or enterprise, whether it is running some running the resolvers and also actually enforcing some local policy. Okay. All right. Now the other protocol is actually the DNS over HTTPS. Now, why people have looked at a different protocol? Why couldn't we just use only DOT? Because the main reason is also that filtering purpose that I explained you before, right? So if the service provider, or if any other party for that matter, if they want to do some filtering, or if they want to do some applying some certain local policies, they could still do all that without much of a problem using that port 853, right? So if you want to actually go beyond that situation, and if you don't want this sort of filtering to happen, then the other option would be actually to send this DNS traffic over HTTPS, right? Because then it becomes more of web traffic, right? And nowadays we can't really filter web traffic, because if you are filtering all the web traffic, then there's not really much use in it, right? Because most of our traffic is all web traffic. So so that's where what you need to understand, the difference between DOT and DOH, right? Now with the DOH, we are talking about some sort of a trust model, right? So what is this trust model we are talking about? Because say, for example, you want your queries to go to a certain place. You could be using a certain application, right? Say, for example, you're using some banking application, right? So you're using this banking application and you trust your bank, right? You keep your money in your bank and you trust your bank and then you do your online banking and things like that. So you have built some sort of a trust relationship with the bank. I'm just taking a simple example here. So then you might say, okay, you do all these things. Why not my bank also run the recursive resolver for me, so that I don't really worry if they know actually the metadata related to my queries because I trust them, right? So bank could be operating my recursive resolvers. So in the same way, depending on the different applications that what we use, depending on the browsers what we use and so on, we could be using some recursive resolvers used by different party, not necessarily our ISP or not necessarily our corporates and so on. Okay, so that is the trust model we are talking about. So we have something called this TRR model when we speak of encrypted DNS. So TRR model is something called trusted recursive resolver. So for example, when you use a browser, you can have some number of resolvers what you trust, right? So those resolvers can be in a list and then you can pick those accordingly. Something kind of, you can build some analogy to the SSL certificates as well, because, in browser we have SSL, the certificate authorities. So we trust them and so we use those certificates, right? So something similar to that as well here, but here we are talking about trusted recursive resolvers. So we have certain resolvers and then we will just use whatever we trust, right? So this trusted party, they can have these what we call this DOH resolver. So DOH resolver is simply a recursive resolver, but they are the other end of the query, basically, right? So client, because earlier I told you that this is between the client and the resolver, and this resolver is what we call the DOH resolver. In between, everything will be encrypted. So this runs on TCP port 443, right? So we know that. So we will run over that. And so that's basically mingled with web traffic. So it's very hard to do any filtering there, okay? All right, so let us try to understand this whole thing using some graphical views. So then the things are much clearer, I guess. Now, if you see the normal or the traditional DNS, right? Traditional DNS, it's like this. You have your browsers, you have your computer, the operating system that I was talking about, the stub resolver, because that's in the operating system. So even from your application to the stub resolver, the operating system, it's unencrypted. I'm talking, this is traditional DNS. So simply nowadays we call it DO53, DNS over 53, right? Port 53. And then from the stub resolver to the recursive resolver all the way, it is still all unencrypted, even to the authoritative servers, it's all unencrypted, right? So this is the traditional DNS. Everything is green. So here green means it's all clear text, right? Unencrypted. So which means, as I told you earlier, if someone is actually monitoring all these things in the middle, they know, they can see where these queries are going, they can see the metadata and so on, right? Now with DOT or DNS over TLS, this is the difference in comparison to the traditional DNS. So it will be, the encryption would be between the stub resolver and the recursive resolver, right? These parts are unencrypted still. I told you, like between the recursive resolvers and the authoritative servers, that is still unencrypted. And also actually between the application and the stub resolver, that is unencrypted as well. That's clear text, right? But here in this case, of course, stub resolver is still our operating system. Okay. Now with DOH, which is DNS over HTTPS, you can see that it's all the way from application to the recursive resolver. Everything is all encrypted, right? So that's the difference. But still, as I told you earlier, from recursive resolver to the authoritative server, it is still unencrypted. But this doesn't really matter, because after this stage, this authoritative server really wouldn't know about the client, because this is now done by the recursive resolver, right? So there's not much of a worry there. Okay, now let us see actually what sort of potential impact, especially given that you are operating your networks, you're operating your DNS services, the DNS servers, recursive servers, and so on. What sort of impact that you have to negotiate now here, right? So now the service providers, they have to negotiate with a new paradigm, right? So what is this new paradigm? First of all, no longer you will not be able to actually do things like regulatory compliances, because in many countries the regulators, they have some certain compliances. Maybe they would ask the service providers to filter certain websites, right? Or it depends, right? So depending on certain certain advisories that you're getting from regulators, ISPs, mobile operators, and so on, you have to apply certain filters, right? So, but then with this, you will not be able to do it, right? And also there are some security implications as well. What kind of security implications? Because the recursive server operators, the ISPs, you also do things like malware protections and so on, right? So if a client is trying to go to a malware site, you could try to block that. Or if there are going to be some responses from a malware site, they could just filter that. But this is also now not going to work, because everything is all encrypted, right? So there are some issues here, okay? And also, there are some other impacts as well. What else? What happens if for some reason, if the DOH resolver stops working, right? Because earlier I told you that now the applications, they can decide your DOH resolver, right? So they can decide who will do the resolution for you, right? So it is not going to be your ISP. I mean, when I say you, I'm using as a client, right? So when a client is doing a DNS query, application could be deciding our DOH resolver. But if you take a layman person, average user, if that stops working, say for example, for some reason, the DOH resolver that is attached to that application stops working, client might not really know that's actually in the application end, right? So they could be just talking to the ISP, or they could be just talking to the mobile operator and say, it's not working, right? Or they might think they don't have connectivity or something. So the ISPs might get more tendency to have some customer calls, possibly, in case if things go wrong, right? So these are some impacts as well. What else? What about things like parental controls, right? Because some service providers, some ISPs and so on, they have implemented some parental controls on their system so that they can filter appropriate content for the households and so on. So even this can have some challenges as well, because now the filtering cannot be done, right? What else? Things like court orders, because sometimes depending on certain court orders in local situations, the courts might order for certain purposes, maybe block certain sites and things like that. But again, even with the DH resolvers, because this is not going to be applicable, because the service provider might not be able to do that, right? All right. Now let's go a little bit beyond the ISPs. Now, earlier the things I was talking about, they are like more related to the internet service providers or mobile operators generally who provide the recursive services, right? What about things which are applicable to broader public, right? General public. What about the laws? Say, for example, for some reason, for any legal issues and things like that. Now, as I told you earlier, your DOH resolver could be in another country, right? If you're using a certain application, the DOH resolver related to that application could be in another country. So if it is in another country, that means in a different jurisdiction, right? So the different laws would apply and things like that. So if there is a certain legality within your country, your jurisdiction, there could be some difficult situations, right? Because there are some issues here because it's not within your jurisdiction, right? So there can be issues in terms of content filtering laws within a given national boundary and things like that, right? And the other thing is actually who gets to determine the DOH resolver. This is also something to think about. Now, as a client, do I get to decide my DOH resolver? That's something to think about, right? I mean, I told you, yeah, basically as a client, I should be able to do that because that's what I trust, right? In my browser, I should be able to decide what are the trusted recursive resolvers I should be using. But if everything works fine, that is okay. But then at the same time, I cannot expect that every user to be same as myself, right? Maybe there could be a lot of users who doesn't even know about all these resolvers or where your DNS query is going and things like that. So who will decide for them, right? That's a question, right? And then the application providers, say the browser vendors or whoever it is, how will they actually let the end user understand this whole thing? Maybe they might just pop up, a pop-up box or something saying that, would you want to use this DOH resolver? But without the normal tendency is that without checking anything, you would just click yes, right? So the end user, the end client might just click yes, whatever, pops up as a, message, they could just elect to take that. So if that is the case, it is not really a proper decision taken by the client, right? So these kind of things are kind of gray area, especially especially how you're going to actually make sure that the client knows what resolver that the client is going to use. And also, what about if the DOH resolver is not really genuine? Maybe they could be just using the clients to make some profits, right? To monetize the DNS data. So they can always actually be, if just in case, I'm not saying everyone is like that, but in case if there are some dishonest application makers, for example, they could provide some DOH resolvers that can benefit them. It could be for various purposes, maybe to collect the metadata, or maybe to monetization purposes. For any of these things, these kind of things can be done. Basically, without the consent of the client, they can actually get the DOH resolver pushed to the client that the client might use it. Okay. Yeah. So to kind of summarize all these things what we discussed, there are a number of in fact we will need to find some proper policy implication towards all these things, because there are a number of areas we need to think about. One is the privacy aspect. This will definitely increase the privacy, which is actually from users' point of view, which is good, right? Because this will provide the privacy for users in terms of their DNS traffic. They can protect it. And also this will provide the assurance for the users that nothing will get filtered, and they can go to where they want, right? And also actually there are other areas, things like circumvention of those filtering aspects that what we discussed. It could be due to those security policies, things like I said, malware protection and things like that, or maybe depending on the local regulatory requirements, there could be some local policies, or maybe any other particular local policies by the service providers, any of these things, right? Or there could be some sort of unwanted centralization that could happen as well, which means if say now, even if you take browsers, for example, now there are only few browsers, right? So even though there are so many of DNS queries or DNS clients and so on, if you really think about the say the applications point of view, if you think of browsers, there are only few browsers. So if these browsers, they decided, okay, all these DNS queries going to go to a certain DOH resolver, right? So then all our queries will kind of concentrate on few DOH resolvers. So there could be some unwanted centralization there. Okay, so this could also be some issue. And then there could be some things related to the speed of DNS responses as well, because now the encryption is going to happen. So encryption would create some performance issues. The TLS connections, these all can relate or end up in performance issues as well. Basically, can get slow, right? So increasing privacy, that privacy is generally good, and then basically, we are encrypting the path between the stub and the resolver. And then this would also prevent attackers from changing the traffic in responses, because in traditional DNS, there are a lot of these replay type attacks, man in the middle type of attacks, and so on. So we can protect those things, because now things are all encrypted. Even for someone in the middle, they will not be able to actually do this kind of things, right? So there is some good things out there. Also, DOT and DOH increase the security, because it's using similar to HTTPS in the web, right? I think I have already explained about this aspect, because filtering based on the policies, and we can apply some local policies, and so this is also something for us to think about, especially things like governments, what laws, jurisdictions could apply in certain cases, right? Unwanted centralization, I think I did explain that earlier in detail. So this is where actually, if just in case, if many of these applications try to use very few DOH resolvers, right? And then there are already some implementations as well. Some browsers, of course, they give some option to the client. But again, say for example, if your resolver operator is not, they're not doing DOH, then they could be actually using another DOH resolver, right? And then sometimes, some browsers, they have certain recommended DOH resolvers as well that you could pick. So there are different implementations here. Speed of responses, I think this also I spoke earlier. And basically, starting the TLS session can be slower because and also, you know, the overloaded resolvers, especially, you know, now if there are going to be a lot of concentration among the resolvers as well, there are going to be a lot of queries coming into a certain DOH resolver. So this might also create some performance issues, and also might have some long TLS startup times as well, right? So these could be some issues in terms of responses. Now, yeah, so with all this, there are a few things just we need to be aware. I think basically this is what I just wanted to summarize things. Now, the applications, what you need to understand is that unlike the traditional model, now the applications will start doing their own DNS based on the DOH resolvers, right? So this will be implemented in web browsers. It could be in mobile apps and things like that. So even in say, for example, in your phone, if you're using many of the mobile apps, unlike before, now your phone could be doing, you know, could be using so many of the DNS resolvers. It could be going in different, it could be in different countries, right? So these different resolvers could be in different countries. So your queries are now not going to a, say your mobile operator, your ISP, they could be all going in so many different places, right? So these could be things that that we can expect. And then what else? So the local policies, I think I explained that. DNS privacy, we had some discussion over that. And then the implementation details. So this is important. I think especially just for you to be tuned in to what's going on, what's going to happen as well. Because if you are building some, if you are in the process of building your own local policies or having some sort of discussion within your, you know, within your regulatory bodies and things like that, you may want to have some discussion around this as well, and see what are the best options in your case, right? So just to have some awareness about this whole thing, right? You know, finally, just wanted to actually quickly update from because I'm representing ICANN. So from ICANN's point of view, these are a few things that you know, we in fact we published some position papers on this as well. So these are our positions. We think that the privacy is always good because that's something that protect users' privacy, right? And also the other thing is that for, filtering of DNS is beneficial. It can be beneficial because for those reasons I mentioned you before, things like, you know, the malware, you know, security, malware protection, the parental controls, these are all good things, right? So for all those reasons, you know, filtering of DNS can be beneficial. And what about the applications and operating systems? These may not have really enough information to take network control decisions, though. This is something to note, because if I'm running an application in my device, that particular application doesn't really know what are the local conditions, what are the policies in relation to a certain jurisdiction, what are the legal mandates, you know, things like that. That application provider knows, you know, they don't have enough information about it. So they are taking a control decision means that's something probably, you know, may not be correct because they don't have you know, they don't have sufficient information. And DNS data should be protected because this is DNS security, and we should always try to protect DNS data, right? So these are, you know, some sort of, you know, positions that we are in. So I think that's what I wanted to convey. So convey mainly to make you aware about this whole encrypted DNS discussion out there, what's happening, and so that, you know, you are aware of this, so that you can also, you know, tune into the things going on, the discussions, and so on. So with that, I think I will conclude my presentation. If there are any questions I can take, or otherwise you can still contact me or be in touch. My contact details are also in the slide. Thank you. Over to you, Subha.
Yes, Champika, thank you. And if audience have if any questions, please post us in the chat box, or you can directly contact the Champika, and his profile is there in the LKNOG website. And before moving to our next session, we'll go for a small break. I think 10 minutes break. We'll be get back in 2:25. Okay, and please stay with us. After small break, please join with us. Hi all. Welcome back after a short break, and we are going to move into next session. Next session is on 5G industry updates and new business insights. It is conducted by Mr. Mecci Abdul Cader. And Mecci is working in Huawei Technologies as a solution manager in core network products, and he has more experience as telecommunication engineer and manager in telecommunication products in Huawei Technologies. And he's very clear about the 5G technologies, as Huawei is one vendor that who are going to launch the 5G technology in Sri Lanka. Yes, Mecci, you can take the screen now.
Thank you, Subhashini, and good afternoon, everyone. I hope you had an interesting session during the morning half. So next time, I'm going to talk to you about 5G, which is a very hot topic these days. Especially everyone is talking about 5G, but everyone still doesn't know how to clearly or properly make money out of 5G. So let's see about the industry current status in terms of 5G, and also what are the new business opportunities or use cases what have been implemented in other countries. So before I start off, we say that history is a good fortune teller. So the first one I want to tell you is, for those of you who are techie fans, you may have heard about Star Wars. So if you take the Star Wars movie, New Hope, back in 1977, produced by Lucasfilm, they did a very revolutionary thing where they projected up a hologram of Princess Leia, where she was able to convey her message to General Obi-Wan Kenobi, who was living galaxies or light years away. So we never thought that these kind of holographic things will actually become a reality, but nowadays we can see that this is becoming reality almost more than 40 or almost 50 years later. So how has this become a reality? So in Vodafone Romania earlier this year, they did a holographic music concert during the pandemic, where they were able to project one of the guitarists, the young boy you see on the screen over there. He was projected holographically from a studio location in another place, and they were able to live stream the concert. So you can check more details on this event down here on the links. The links are over there. So this is what technology has brought. So something that was foretold almost 45 years ago is now becoming a reality. So how has this become a reality? So let's see what are the trends and the industry situation in terms of 5G currently. So 5G, previously people were looking at things which were like value for money. So they were looking for higher bandwidth consumption, low latency applications, service-centric factories and high-end factories, urban environments to collect all kinds of metadata, connected everything. So some countries, they do this kind of public surveillance and all this. Tele-robotic healthcare, this was another very interesting topic which the industry was looking at. But now, over the next 4 or 5 years, we need to look at something totally different. We need to look at what is going to bring value for many. So this is what 5G is all about. So some of the concepts are 4D printing, mixed reality living, mesoscopic devices, real-time interactive communication, uplink-centric broadband communication, and harmonized communication and sensing. These are the technologies or the thinking that are there in the higher levels of the industry, and how they are planning to evolve their telecom networks in the world to 5G. So 5G transformation has taken a long way. So there have been 3 phases. Phase 1 was mainly focused on strategy. So people were looking at fixed wireless access or enhanced mobile broadband as their primary drivers for 5G. They were focusing on a higher downlink speed and also a relatively lower latency, which was the initial focus. Then we went on to the strategy changed to a new domain where we included the public domain. So 8K video, virtual reality, HD 360, all of this kind of technology started to come in where they required lower latencies. Furthermore, these applications started to require higher bandwidth compared with the initial phase one. And over the next 2 or 3 years, maybe even 4 years, what we will see is new business cases coming in through technologies such as low latency communication, massive machine type communication. All of this will bring reality, will bring more reality to what we thought was not possible maybe 10 years ago. So holographic communication, VR, drones, all of this will come into the picture in the next 3 to 4 years. So this is where the 5G industry is heading. Bandwidths will be huge, more than 1 Gbps of burst speed requirements for these kind of applications, and a latency of less than 10 milliseconds, which is very difficult to achieve in the current situation. But this is where the industry is heading. This is where the technology is going. So for the roadmap to 2025, there are 3 main focuses what people need to look at, operators are looking at, vendors are looking at. So basically, technology focus. So in terms of technology, currently they are looking at cloud native technologies, flexible topologies, closed loop automation. But in the next 3 to 5 years, they need to look at extreme performance, distributed AI, gigabit anywhere, ultra automation, and differentiated experiences. So this is where the technology is heading over the next 3 years or 4 years. Furthermore, we come into a new business domain. Previously, operators were focused more on B2B kind of services, but they need to look at B2C cases as well. So in B2C, currently we see holographic communication. Few small cases are there. Situation response services. These are what are there currently. And in the next 3 to 5 years, we'll see things like lifelike holograms, extreme AR and extreme VR, immersive reality experiences, Internet of Senses. This is a new concept which is in the pipeline. And also we'll see things like Internet of Abilities. For the B2B business case, we come up with some new technology again here as well. Currently, we are focusing on Industry 5.0 services, digital twins and automation, and we are looking at some cases like collaborative surgeries in some medical industries. And over the next few years, we'll see ICT for climate services, MTP latency applications, brain-computer interaction services. This is also something which has been seen in thoughts of certain places, but these are things which can become reality over the next few years. So this is the roadmap for 2022, which can bring a value for many. So value for many is how operators will be able to monetize their 5G services. So 5G's journey to maturity has been a long one. We had the initial release of 3GPP back in 2018, release 15. In 2020, by June, they finalized the release 16. And by March or April next year, they hope to focus and they hope to finalize release 17. And after that, they'll go on for 18, 19, and so on. So in the release 15 stage, mainly the focus was on eMBB, like I mentioned. They were focusing on NSA to deliver higher bandwidth to the customers. SA architecture was also developed. And once we come to release 16, they are enhancing this eMBB services further by going for MIMO enhancement, FTD, NR enhancement, and UE power saving. So these are things which they have enhanced in terms of eMBB. Digitalization of the industry is also something what they focused on. And so they introduced the low latency communication, V2X cases, and also positioning cases were brought forward. In release 17, they are introducing another new topic, which is massive machine type communication, MMTC. So here again, there will be further enhancements for eMBB. IoT will again take up another step forward, where they move into an enhanced version of NB-IoT. And also we will see side link UE coordination technology emerging after release 17 is finalized. So currently in the industry, there are 162 commercial 5G networks. This is as at April 2021, with 435 operators already investing in 5G deployments. So this is the current situation. As you can see, the growth has been almost exponential. And up to April 2021, we can see more than almost 435 operators who have invested on 5G technology, and more than half of them are already commercial. So if you take the business model assessment, there are three main categories how we can categorize the operators and their business models. So whether they want to become innovation catalysts, where they will be driven on based on novel experiences, their business case will be the primary focus, and their business analysis will come on later. So these kind of operators will be focusing on things like holographic security, total experience, live broadcast demands, and XTech. Next, we see the efficiency seekers. So efficiency seekers are people who, or operators who are focusing on the business case analysis first and try to find the potential what they can generate. The deployment is after the business case has been analyzed and shows a positive return. So these kind of operators will focus on UP or uplink monetization scenarios, smart events, connected campuses, connected stadiums, and Industry 4.0 automation. Then we come to the laggards. So laggards are people or operators who will see what has been implemented in other countries and then develop their business case based on those before they go to market. So here they will focus more on the easier technology first, such as faster download speeds, smoother video, smoother experience, and providing large screens as a service. So these are the three categories into which telco operators are categorized. So if you take an example, SK Telecom, as you know, South Korea is a leading country in terms of 5G deployment and maturity. So SK Telecom, together with Jump Studio, have come up with several 3D modeling techniques. They've used Microsoft volumetric technology, and they have fully automated the process from the mesh construction to motion generation, and they're able to produce high quality end results with authentic looking holographic humans. So this is the case that I showed you at the beginning. The next thing is they have come up with high quality 360-degree 3D holograms with multiple cameras which shoot 60 frames per second. So this way they are able to significantly reduce the time and the cost by automating the existing processes, and they are able to produce more immersive media content. So as you can see, up to 600 gigabytes of raw footage from a 1-minute production shoot is compressed into a 300 MB file. So this can be streamed to mobile services via MPEG-4 files. Furthermore, with the Jump Studio, global fans are able to enjoy concerts and performances by artists in South Korea. And you can see here, it takes, you can see how long it has taken actually to produce this holographic performance. It has taken 3 to 4 months and hundreds of millions of Korean won to create a 3-minute content with 3D modeling technologies. So this is what South Korea are doing. They are innovating, they are developing new business cases, and they are rolling it out into the market. So when we take what the thinking of South Korea or South Korea Telecom is, their business model, like I said, they'll be using new business models. So holograms are advertisements by and for themselves. They will be leveraging the existing 5G ecosystem, and they are using proven vendors such as Microsoft volumetric technology, Jump Studio. So they are using these proven vendors who have demonstrated technically leading skills to monetize their business. In terms of their strategy, they will be taking, producing their own content, their own media, and they will be using the 5G content as their business. So this is their strategy. In terms of the organizational structure, they have a dedicated team, and they are collaborating with Jump Studio professionals to develop this kind of content. Their products and pricing, you can see here how it has turned up. Jump VR, they have 3 million subscribers and 600,000 monthly active subscribers. And they are forecasting up to 10 million subscribers by the end of this year. They're cooperating with PCCW, and also they have plans to expand into US and European markets. In terms of customer experience, they are focusing for the wow effect. So like I said, they are producing new technology which nobody else is having. So they are innovating and they are going for the wow effect. So this is about an innovation catalyst. So next one is we see about the efficiency seekers. Efficiency seekers are people or operators who are looking at improving the current processes. So an example is the 5G smart campus of Aramco Saudi. So one of their plants in Abqaiq, they have implemented the 5G technology. They are using this for things like data collection, surveillance, production scheduling, emergency command, analytics, and also for production planning and production decision making. So this is how they are trying to fully automate, or they're trying to automate the current process of manual work and achieve some kind of efficiencies. So for this kind of operators, their strategy, their business model, everything is a little bit different from the innovation seekers. So if you take the business model, they are focusing more on B2B kind of services. They are focusing on partnership with the existing industry players who have the requirements for things like 5G industry campuses. They are focusing on having a single architecture with several use cases, things which they can replicate in so many places. In terms of the operating model, they use old use cases where the chain is proven and they are handled by 2 teams inside the OpCos themselves. And if they look at the product and pricing, there's 2 examples which I didn't show here, but I will be showing later. So connectivity at Wembley, 5G for the Cup. This is where EE UK made Wembley Stadium the most connected stadium in the world. I will show you an example later on. And also FIFA Euro 2021 is also expecting, or they have done some kind of new technology innovation with 5G. In terms of customer experience, they are trying to go for more time-sensitive networks for 5G and also focusing on the industry 4.0 industries to improve the user experience. So the third category are the laggards. So these kind of operators, they are focusing on the existing infrastructure, the existing business cases, and seeing how they can improve those. So an example is the convergent 5G home by Zain or TRCSL. So here again, they have come up with new technologies to increase or improve the bandwidth. 3+1 in-depth convergence, where they converge the large screen, the social media, and also multi-screen interaction. They are also looking at projection to further development catalyst. They are looking at higher bandwidth from 15 Mbps all the way up to 100 Mbps with 120 frames per second. So this is what these kind of operators are doing. So you can see some of the use cases for video chats, streaming, games, mobile phone to projector, projecting what's on the mobile screen. And also they can view from cameras at scenic spots, and VR and projection. This is another case where these operators are focusing on. So the laggards have a totally different thinking pattern. So for them, they are focusing more on convergence. Like I said, large screen, sociability, and multi-screen interaction. They will leverage the existing ecosystem such as 4K cameras and maturing smartphones, large screens, and also they will be focusing on making people's lives better. So they will focus on what are the emerging demands and try to address their solutions for this. They have in-house teams to study these opportunities, and this is how they come up with their operating models. And they consider how they can differentiate their services and innovate their tariffs compared with the competition in order to achieve success. And also, in terms of the customer experience, they will go aggressively to position 5G by explaining how it will improve the lives of the consumer, of the business, and they will attract more customers out of this. So typical examples, like I said, TRCSL and Zain, these are what we consider laggards in terms of their business implementations. So the next part is 12 use cases for 2025. So, you know, in Sri Lanka, we had the pandemic within about the last 1.5 years, and many people were stuck at home. Many people couldn't go to work. There was a lot of disruption in the economy, but 5G can help to solve most of these issues. So let's have a look at some of the 12 use cases. There are many more. Like I said, the hologram is one example. Nobody thought that holograms will become reality, but now 45 years later, it has become reality. So this don't limit your thinking just for these 12. These are ideas where you can develop more use cases which are more specific for Sri Lanka. So the first case, like I said, Wembley 5G for the cup. So EEUK together with their partners Visualize, they came up with a promotional campaign with at Wembley Stadium where they did augmented reality portals, 360 videos, watch along events, and also they did the match day live and manager mode services or streams, and they also came up with augmented reality portals. So this was a live broadcast, and they were able to give this kind of augmented reality experience to their customers who were not able to go and visit the stadiums, who were watching from their homes. So this is one of the use cases where a sporting event was taken to the fans at home, and they were able to have the virtual experience as if they were at stadium itself. So this is the first use case that I wanted to tell you. In case you have any questions on any of these, please feel free to interrupt me and ask. I'd be more than happy to answer your questions. The next use case where is about a 5G private network at a hospital. So you know, medical industry faced a lot of challenges. People were not able to visit their doctors. They were not able to carry out surgeries. They were not able to do their consultations. So with 5G, the Xinjiang People's Hospital in China, they were able to do 3D image reconstruction and 3D MR image display. They did remote surgery. You may have seen there were some use cases, or there was some media publicity for this also several months ago. So this is the second use case where they combine 5G with edge computing and slicing. So all three combined together, they were able to achieve this kind of remote surgery and 3D image reconstruction for the medical industry. So this is a case from China. This was started in 2019, and they saw reality in 2020. Third case is again from South Korea. So Sri Lanka is a country which is very much dependent on tourism. So this case is very much close to Sri Lankans. Changdeokgung Palace, this is a historical palace or historical site in South Korea where a lot of tourists go to visit. It's a UNESCO World Heritage Site. Similar to Sri Lanka, we have our own UNESCO World Heritage Sites. So the South Korea Telecom, they came up with the technology where people could experience, or they could walk through the site through their mobile phones with 5G technology. So people who are unable to visit due to the pandemic, they can choose the service and experience as if they were at the same place from their home, from the comfort of their home. So this was the case where SK Telecom introduced 5G powered AR augmented reality tour for Changdeokgung Palace. So this is another use case which can be replicated in Sri Lanka. The fifth one is also another medical case. So here it's from Korea Telecom and Samsung Medical Center. They built the 5G smart hospital. Again, they were able to provide access to digital video and video footage and data remotely. They were able to do surgical education away from the operating room because the operating rooms were too crowded. People were able to do surgeries from far away. They were able to use robots for operating room assistance and artificial intelligence for inpatient care. So these are some new technologies what KT and Samsung Medical Center implemented in South Korea. So they came up with the 5G powered smart hospital. It was the world's first application of 5G technology in medical practice. And it also made a secure base for the medical service deployment and development in the country. Sixth use case, gaming. This is a case from AIS Thailand. Sri Lanka is also having quite a lot of gaming enthusiasts now. We see many esports events, gaming championships happening online. So AIS have come up with, together in partnership with a company called Blacknut and Gameloft. So they came up with the cloud gaming solution on 5G. So here again, they were able to give a upgraded gaming experience in a new format for the Thai people with AIS 5G cloud game service. So they were using the 5G technology and also allowing the innovation that it was bringing with it to allow gamers to play these PC and console games on their phones itself. So the gaming industry is worth around 70 million a year, and Thailand, they have more than almost many numbers of millions of gamers who are new to this experience, and they are enjoying this service. You can see the pricing that they're doing, it's around 299 baht per month, and any compatible smartphone can be used to experience this service. So this is about cloud gaming from Thailand. The eighth use case, again, this is about 4K and 8K production and broadcasting. 5G came up with high bandwidth applications, which is what people are still enjoying mostly in many countries. So 4K and 8K video production and broadcasting, this was implemented in China again. So they came up with this concept where they were able to enable at least 10-channel 4K level bitrate processing capacity. And also the platform was able to host a lot of editing applications to facilitate live streaming. It supported integrated production. And also it was able to meet the demands of China Media Group in terms of video editing. So they implemented network slicing in order to get the dedicated slice allocation for their services. And this is how they implemented this 4K and 8K production and broadcast platform in China. The next one, again, we go back to Korea. So LG U+, they have a concept or a target to be the best network in the world. So their slogan is U+ 5G 3.0. So here again, they are focusing on delivering more services to the customers while they're at home, which they would normally enjoy outside. So you can see home training like exercise training, sports training at home, VR gaming, AR or augmented reality shopping, 3D AR kids library for children's entertainment and education. So these are some of the cases which LG U+ implemented in their 5G 3.0 portfolio. So based on the growth that they experience from this service, the customers we are expected to constitute around 40% of their total user base by the end of this year. So this is the market space that they are forecasting to achieve. The 10th one, Tokyo 2021, this one you will be able to see it very soon. So Tokyo 2021 together with Intel, they are connecting, they are trying to do a lot of new technology, a lot of new things in terms of 5G. So one of them is, again, like I said, holograms. So they have done a demonstration recently at NTT Lab to show the technology that they are going to use for the Tokyo Olympics, and also how they are going to bring many types of sports to the home itself, so that the user can have a more immersive and a more rich experience. So they are hoping, or they're expecting, that the forthcoming Olympics will become this virtual reality experience so that sports fans can enjoy their stars performing while they are far away. So this is, they're going to do things like AR, VR, and also they're going to do things like training assistants and esports events and even a theme park. So these are what they are planning to do. You can check more details on the links which I have shared below. The 11th one, smart port. So smart port, this is another new thing which is helping to drive the economies of countries. So, while we had the pandemic situation, the harbor in Sri Lanka, it lost a lot of business because the employees couldn't report to work. They were unable to travel. They were under lockdown in wherever their hometowns were. So this is also something which can be replicated in Sri Lanka. So with the smart port, what we can do is we have the remote operated services such as smart tallying, automated logistics and unmanned container trucks, remote controlled 5G based tier cranes. So all of these are able to improve the efficiency. Now, if you take the traditional kind of a port, you need one person operating each crane, you need one person operating each truck, and also you need one person doing all the tallying. But with 5G, what we can do is we can increase the efficiency by up to 4 times. So you can have one person controlling 3 or 4 cranes because obviously all of them are not working at the same time. So you can have one person who can control 3 or 4 cranes. Your staff numbers are reduced. And even if you have a situation like what Sri Lanka faced, we'll be able to overcome it because you don't need to have that many people reporting to the site. It will also give the employees a better life because they don't need to risk their lives to climb to the top of the cranes. They don't need to risk their life by walking or traveling under containers which are hanging overhead. So this is also something which can help to improve the working quality for these employees at the ports. So this is another technology which was implemented in Ningbo, Zhoushan, back in China. 12th use case is a live uplink broadcast. So 3HK have come up with a 5G new service called 5G Live Up solution. So here again, people are able to stream their lives. They are able to experience or they're able to share what they're doing in terms of their day-to-day lives with massive numbers of population. So 5G is now starting to go live in Hong Kong, and 3HK are taking advantage of this to come up with this new kind of services. So they have launched a campaign called Live KOL, so where they have the training academy for their social media influencers to learn and how they can develop their streams on this platform. So these are some of the 12, these are just 12 of the use cases what have been implemented in many countries. I hope it was useful for you. So next thing we need to look at is 6G. So people are starting to talk about 6G. So I hope that you would consider or you would take note of what I have shared and see how it can be evolved into the next generation 6G technology. I hope you are clear with my presentation, and if you have any questions or any doubts, please feel free to raise it up. Subhashini, I think no further questions. So if anyone has any questions, you can maybe collect it and share it with me. I will be more than happy to answer. Thank you.
Okay, thank you, Mecci, for the valuable session today. With the short notice, you accept the challenge and deliver a very good session to us. Thank you very much. If audience have any questions, please post in the chat window or you can direct to us. And we'll be posting Mecci's profile in our LKNOG site, and you can contact him also. And we'll move to next session. This is related to Sri Lanka Telecom IX updates, and Mr. Kaushalya from Sri Lanka Telecom will be doing the session. And Kaushalya is with the 10 years of experience, more than 10 years of experience in SLT global network and IX operations as a peering administrator. Also, he's our LKNOG secretary. Kaushalya, you can use the screen now.
Yeah, thank you, Subha. Hope you see my screen.
Yes, Kaushalya, you can continue.
Yeah, of course. Good afternoon, everybody. So actually now this is on Sri Lanka Telecom Internet Exchange. If it's the SLT-IX, so it's actually not on the Sri Lanka Telecom traffic. It's actually the national traffic which we are talking about now. It's the now with this the pandemic situation, so we see that the big traffic growth, the local traffic growth. So all these traffic generated from the consumers of Sri Lanka and the passed via these local ISPs and the exchange at Sri Lanka SLT-IX. So that's what the point, the concentration point, that is where the concentration and the exchange happens. So this hope you see my screen, right?
Yes, Kaushalya, we can see your screen.
Yeah, but it's not scrolling. So, all right, that's okay. So now, actually, what we experience in this pandemic time, before the pandemic, let's say early 2020, so we exchange our total traffic that was around 1G, 2G traffic. So that is actually the total traffic cumulative from all the local ISPs like SLT, Dialog, Lankabell, Lankacom, Mobitel, and all these the locally registered ISPs. So that is within 1G level. So, but right now, that rose up to 10G level, and the peak time also changes. That is now due to the online schooling and online office activities. The peak time is around 9 to 10 a.m. And that is the significant change in the local internet industry. And from the ISP SLT-IX perspective, we have a couple of members join Lankacom and Learn. So now almost all ISPs connected to SLT-IX. That is what I want to give as the update. And this is the one-day traffic profile. So you see that we comes on to it's a one day. It's July 6th. I have taken July 6th full day traffic. So you see that it's around 10 a.m. So we will have the biggest traffic. So all this traffic, as this IX focus on the local traffic. So this is generated from the schools and the office people who are working from home. So everything the host the destinations are also within Sri Lanka. So this is what we focus. This is the main objective actually on the SLT-IX. So we need local traffic remains local, and the performance improvement due to the delay, the shortening of delay. So that's what we think now. This is the we are very happy that we are a part of and the contributor for I mean the contribute the for the making a conducive environment for the local internet users. So that is what SLT-IX has done. So these are the members of IX. You see now from Tata, SLT, Lankacom, Lankabell, Mobitel, Learn, Airtel, Lanka, and Dialog. So all are exchanging local traffic at SLT-IX platform. So this is the technical, high-level technical diagram, which contains 2 route servers and a layer 2 platform for physical connectivity. So that is the and we are optimistic that as of the as when we see the growth, so there will be more growth. So once these other applications like the web services on the traveling and some e-commerce applications and the gaming software, the gaming applications. So once those are located within Sri Lanka, maybe on the data centers in Sri Lanka, so we think that there will be a lot more traffic. And the content on this education sector also, there's a big avenues. So we hope that IX has a good point to develop, and happy to cater on the local internet users and the industry. So, and what we plan next. So we are on still we are on a development stage for some visibility. So actually now these are on the housekeeping activities. So we are looking on a new route server addition, and we are going on for more visibility on the network, and we need to improve 24/7 NOC service, which is already in place, but we need to go for more enhancements. So that's what I want to share with you. So hope we all can contribute to the and make some relief for the Sri Lankan community who are having a lot of issues in this pandemic situation. Thank you very much.
Thank you, Kaushalya, for updating us regarding the IX status. Actually, now that all the technical presentations are over, and it's time to wind up our conference. I'm very happy, and it's fair to conclude that this was a successful knowledge sharing event. I believe that all the participants, they have taken good things from the conference. And I'm indeed privileged to propose a vote of thanks on the closure of LKNOG5, happened the 5th consecutive time. On behalf of the conference committee, I would like to extend my sincere thanks to SANOG for the partnering with us, the great support from SANOG committee while moving physical event to online, and great understanding with all the difficulties that we could overcome. Also, I'm thankful to the Lanka Education and Research Network, the partnering with us for the technical support. I thank you very much all that give us the great support, coordinating the event with the technical support. And next, our keynote speakers, Dr. Oshada Senanayake, Director General of TRCSL, Dr. Asitha Bandaranayake, CTO of Learn, Dr. Prasad Samarasinghe, Managing Director of Lankabell. Thank you, sir, for your great knowledge sharing and your time despite the busy time schedule of you. Next, our speakers, Mr. Ron and Dr. Philip, Ms. Champika, and Kaushalya Mecci. Thank you all for your participation and valuable technical sessions delivered. I'm sorry, there's some noise outside. I cannot forget the support of the conference chairs and the moderators of all the conference sessions. We owe a special gratitude for all of them. Well, an event like this cannot just happen overnight. A lot of planning needed to be done organizing this. We have been so fortunate enough to have dedicated and motivated conference organizing committee, especially the remote coordination with huge effort is really appreciated. I would like to thank all the participant speakers who joined from different time zones with the flexibility. We hope LKNOG5 will be a physical or hybrid event, and we look forward seeing you in Sri Lanka next year and enjoy great Sri Lankan hospitality. Till then, follow our activities to connect with us through our mailing list and social media. Thank you. Thank you very much for all the support given to make our LKNOG5 event successful. Thank you all.